Good morning, everyone. I take this opportunity to welcome each and everyone who is part of this event physically as well as virtually. It's my privilege to welcome Honorable Chief Minister of Goa, Dr. Pramodji Sawant, Honorable Minister for Science, Technology and Waste Management, Shri Atanasio Montserrat, Chairman GPSC, Shri Jose Manuel Noronha, Chief Secretary, Government of Goa, Dr. Puneet Kumar Goel, IAS, Secretary, Science and Technology and Waste Management, Shri Ramesh Verma, IAS, Professor Sunil Kumar Singh, Director, NIO, Professor Christopher Brett, Professor, University of Coimbra, Portugal, who has come all the way for this prestigious Vidnyan Mahotsav. Dr. P.S. Goel, former Secretary, Department of Ocean Development, Ministry of Environmental Studies, Government of India, Professor Raghavendra Gadakkar, Professor, Indian Institute of Science, Bengaluru. I also welcome each and every participant who is witnessing this event being held at various places like Ravindra Bhavan Sakli, Birla Institute of Technology, Vasco, Government College Pedne Goa, Government College Arts Science Commerce Kepe, Government Higher Secondary School Kankon, Rajiv Gandhi Kala Mandir Ponda, and Don Bosco College of Engineering Fatorda Margav Goa. Your presence really makes us happy. An epitome of integrity and dedication in public life, a true patriot, exceptional administrator, affable personality and accessible nature, known for his honesty, simplicity, passion and enthusiasm, an unparalleled leader, Manohar Parrikar. Government of Goa, Department of Science, Technology and Waste Management is organizing Manohar Parrikar Vidnyan Mahotsav 2022. And we are pleased to have our dignitaries amongst us. Once again, I extend a hearty welcome to all dignitaries, officials, students, and media. And now I request Chairman Advisory Committee, Sir Jose Manuel Noronha, to welcome this august gathering and also to give an overview of Manohar Parrikar Vidnyan Mahotsav 2022 4th edition.
A very good morning to all of you, Honorable Chief Minister, Honorable Minister of Science and Technology, secretaries who are here, members of the advisory board. I will just run through a very brief of the events that we had for the last 3 years, because this is the 4th time we're having it. And after I finish the three-minute brief, I'll have a small movie displayed in memory of Mr. Parrikar. That's about 7 minutes. So do take a look and enjoy it.
Science and technology are the wheels that propel society towards development, encouraging innovation. Science and technology are the wheels that propel society towards development, encouraging innovation, and improving the standard of life for all. The state of Goa, which boasts a high rank in key human development indicators, is rapidly embracing cutting-edge technology in its infrastructure, education, economy, and administration. A leading Goan policymaker who has contributed to the development of science and technology in the state is the former Chief Minister, the Padma Bhushan, late Shri Manohar Parrikar, who visualized sustainable development driven by science and technology at the core of state policy. The Cyber Age scheme introduced by him to distribute computers and laptops to students made technology accessible at the grassroots and in the classrooms, stimulating young minds to develop a scientific outlook. Today, this digital revolution has reached all corners of Goa. An IIT alumnus, Shri Parrikar led many milestone initiatives that provided the best avenues for young minds to acquaint themselves with cutting edge of scientific and technological knowledge. He was instrumental in setting up prestigious campuses including IIT and NIT in Goa. Late Sri Parrikar initiated and promoted students' involvement in innovative ideas and projects that help solve environmental and social problems. With support from the Department of Science and Technology and Waste Management, the Goa Waste Management Corporation was established. 2 integrated solid waste management facilities are in operation, working to solve Goa's waste management issues using advanced technology. Taking science and technology to the doorstep in order to develop scientific temperament, a 2-day Nobel series was held in 2018. This initiative brought together various stakeholders dealing with science and technology. In his inaugural address, late Sri Parrikar opined to make Goa a permanent venue for such events. The untimely demise of Sri Parrikar in the year 2019 created a void in the scientific and political arena. However, his vision and ideas are now being taken ahead by his successor, Dr. Pramod Sawant, Honorable Chief Minister of Goa. The yearly Vidnyan Mahotsav is the testimony of his commitments.
नमस्कार. डिपार्टमेंट ऑफ सायन्स अँड टेक्नॉलॉजी अँड वेस्ट मॅनेजमेंट या डिपार्टमेंटाच्या वतीन आम्ही 4th एडिशन ऑफ द मनोहर पर्रीकर विज्ञान महोत्सव 2022 हाजें आयोजन करपाचें ठरयलां. 13 डिसेंबर ह्या दिसा ह्या महोत्सवाच्या निमित्तात आमी देशभरांतले 17 सायंटिस्ट हे आमच्या गोंयांतल्या सगळ्या स्टुडंट्स कम्युनिटी कडेन उलोवपाचे आसात. त्या खातीर समेस्त लोकांक आनी स्टुडंट्सांक खास करून कळवणी आसा की वेगवेगळ्या जाग्यांचेर हाजें आयोजन ह्या कार्यक्रमाचें केलां आनी त्या निमित्तात आमकां इंटरनॅशनल 17 सायंटिस्टां कडेन उलोवपाची संद निश्चितच रित्या आमकां मेळटली. मनोहर भाई पर्रीकर हांचें स्वप्न आशिल्लें की गोंय हें IT आनी टॅक्नॉलॉजींतलें हब जावचें, इनोव्हेशनचें हब जावचें आनी तांचेंच हें उतर फुडें व्हरपा खातीर आमी सातत्यान गोंयांतल्या सगळ्या भुरग्यांक अशाच विज्ञान महोत्सवा कडेन जोडून दवरपाचें काम हे गेली सातत्यान 4 वर्सां करीत आसा. म्हाका सांगपाक खूब खोस भोगता, ह्याय वर्सा हो कार्यक्रम खूब मोठ्या प्रमाणांत आमी आयोजन केला. तुमी सगळे जाण डायरेक्ट ना जाल्यार वर्च्युअली ह्या कार्यक्रम जॉयन जातले आनी हो कार्यक्रम यशस्वी करपा खातीर तुमचो सगळ्यांचो हातभार लागतलो.
Since 2019, Manohar Parrikar Vidnyan Mahotsav has set a glorious tradition of exchanging scientific ideas. To date, around 15,000 students have been part of this Mahotsav. Learned minds, including Nobel laureates and scientists of international repute, shared their insights and experience on this platform. These include Professor Ada E. Yonath, Professor K. Kasturi Rangan, Professor Ajay Kumar Sood, Professor Randeep Guleria, Professor Padmanabhan Balaram, Professor Shailesh Naik, and many more. The grand interaction with intellectuals has been a deeply enriching experience for the young students participating in the initiative.
Manohar Parrikar Vidnyan Mahotsav is a great opportunity for all our students to learn many things. It helps us create a base for our future inventions.
Give us an opportunity to understand science in a better way.
This event brings many scientists from different parts of the world for us students to gain knowledge of science and its discoveries.
It actually helped me to know about the inventions and helped me to be firm with the decisions I want to take in the future.
Late Sri Manohar Parrikar had a lasting impact on Goa, and the initiative that bears his name also promises to have a deep impact on the thinking and innovation activity within the state. Goa is certain to attract the brightest minds from across the global scientific community. With such initiatives, backed by the government of Goa, will surely help in evolving Goa as a hub for science, technology, and innovation.
A speaker who's come from abroad, Professor Christopher Brett. We have with us Professor Raghavendra Gadakar, Professor Goel, who is here with us, who will deliver a lecture a little bit later. We have 7 more centers in Goa, as you would all know, where we have Dr. Tessie Thomas, we have Professor Arindam Ghosh, we have Dr. Ashish Lele, Professor Jana Gaudar, we have Dr. Parminder Maini, Professor Janartham, Dr. V.K. Singh, Dr. S. Chandrasekhar, Dr. Sindhura Ganapati, Dr. Purnima Jalihal, Dr. Tapas Kundu, Dr. Kamakoti, who is the director of IIT Madras, Dr. Anil Bardvraj, and we have a virtual lecture from the US from Dr. Andrea Colasso, who happens to be from Goa. Welcome once again, and do enjoy the session today. Thank you.
Thank you, sir. Kindly take your seat. Thank you once again for these warm words of welcome, and it was really nice to see the positive approach of the students towards this Vidnyan Mahotsav. I request all the dignitaries to light the auspicious lamp and inaugurate this 4th edition of Manohar Parrikar Vidnyan Mahotsav 2022. We begin every work by lighting the lamp, and we believe it spreads positivity and makes the occasion vibrant where it is lit. Thank you, all the dignitaries. I now request Director Science and Technology, Sri Levinson Martins, and NIO Director, Sri Sunil Kumar Singh, to escort the dignitaries on the dais. A warm welcome. Welcome. Welcome, sir. Flowers make people better, happier, and more helpful. They are sunshine, food, and medicine for the soul. May we now present flowers to all our distinguished guests. Honorable Chief Minister of Goa, Dr. Pramod Sawantji. Honorable Minister for Science, Technology and Waste Management, Shri Atanasio Monserrat. Chairman, GPSC and Chairman Advisory Committee, Shri Jose Manuel Noronha, sir. Chief Secretary, Government of Goa, Dr. Puneet Kumar Goel ji, IS. Secretary, Science, Technology and Waste Management, Shri Ramesh Kumar Verma ji, IS. Professor Sunil Kumar Singh, Director, National Institute of Oceanography. Professor Christopher Brett, Professor, University of Coimbra, Portugal. Dr. P.S. Goel, former Secretary, Department of Ocean Development, Government of India. And Professor Raghavendra Gadakkar, Professor, Indian Institute of Science, Bengaluru. We are delighted to offer the most hospitable welcome. Thank you. I now request Director NIO, Professor Sunil Kumar Singh, to address the gathering.
Honorable Chief Minister of Goa, Dr. Pramod Sawant ji, Honorable Minister of Science and Technology and Waste Management, Government of Goa, Sri Atanasio Monserrat ji, Sri Jose Manuel Noronha ji, Chairman, Goa Public Service Commission, Sri Puneet Goel ji, Secretary, Chief Secretary, Government of Goa, Professor Christopher Brett, Coimbra University, Portugal, Professor P.S. Goel, former Secretary, Department of Ocean Development, Ministry of Persons, Government of India, Professor Raghavendra Gadakkar ji, ISC Bangalore, Sri Ramesh Verma ji, Secretary, Science and Technology, the other dignitaries, scientists who are participating in this meeting, my dear students, coming from different parts of the Goa, it gives me immense pleasure to welcome you all in this 4th edition of Manohar Parrikar Vidnyan Mahotsav. We are at CSR NIO and CICR is associated with this Mahotsav since last 4 years, since the beginning. Today our DG, she is not here because she is busy with some other engagement. So I am welcoming you on her behalf and on behalf of myself to all of you in this gathering. Everybody will agree that science and technology is the backbone for all-round development of any country. And we also are aware that we were very advanced stage in science since the beginning of the human evolution. So now, you know, if you have to become #1 in the world, science and technology is the only way. And this was realized by many of our leadership, and our Manohar Bhai ji, he thought about the science and technology, and he initiated this initiative to inculcate the scientific temper in all the young students to make the country go forward in all the direction. So this initiative, when it started, I think you are part of that since the beginning, and we believe that this is the only way to make an all-round sustainable development of the country. Generally, everybody thinks that Goa is a place for tourism and fun-loving people. But as you have seen, Goa is a real education hub with so many educational institutions and research institutions. It has potential to become real education and technology hub, and I'm sure that this type of meeting will bring it further toward that. So without delaying much, once again I welcome you and hope this will go a long way. Thank you very much. Welcome you again.
Thank you, sir. Now I take this opportunity to invite Chief Secretary, Government of Goa, Shri Puneet Kumar Goel, IS, for his address. Dr. Puneet Kumar Goel.
Honorable Chief Minister, Goa, Dr. Pramod Sawant, Honorable Revenue Minister, Mr. Monsarat, Shri Norona, Chairman Goa Public Service Commission, all the other dignitaries on the dais, eminent scientists who have come from different parts of the countries and from the world. I welcome you all for this prestigious event. It is really an honor for me to be present on this prestigious Manohar Parrikar Vidnyan Mahotsav 2022, which is a science festival and is an annual event benefiting more than 5,000 students directly, besides several others through online platform, which is on the day of birth anniversary of our ex-Chief Minister of Goa and ex-Defense Minister, Shri Manohar Parrikar. As we have seen in the movie, our ex-CM put many seeds, like there is a waste management plant, the airport, and these seeds now slowly are being converted into plants by our present CM, and they will soon become big trees, and which will be examples for the entire country and for the entire world also. So this festival is an opportunity for our Goan students to remember our beloved ex-CM and to directly interact with scientists of international repute and get motivation to follow the path of science, technology, and innovation. I believe that scientific temper is not required only by the science students or the engineering students or the medical students. It is required by everybody, even the art students, humanities students, the commerce students. Scientific temper is a way of thinking rationally, questioning everything which is told to us by others, questioning and believing by analyzing in our mind. So I am sure this festival will help all our students, and not only students, even the adults, to develop this scientific temper. This motivation will lead to having scientific minds which think rationally for a progressive society in the near future towards the progress and prosperity of this nation. I myself, being a ex-IIT alumnus, it is a very proud moment for me to be present here and an example for all of us that how a person from science and engineering background can lead the nation and others can just follow his path. As a government, we have always supported the research minds in undertaking cutting-edge research and innovation activities through various schemes of Department of Science and Technology. Teachers and researchers are trained periodically on recent advancement of science and technology, which benefit in their teaching and learning process. Department of Science and Technology also has a scheme wherein researchers and students are sent outside the country to present their research papers and exchange the ideas. I am sure this initiative of Government of Goa will go a long way to achieve our Goa, to make a Goa state a scientific hub. I request all the students to take maximum advantage of this Mahotsav. Thank you, sir.
Thank you so much, sir. We are pleased with the presence of Honorable Minister for Science, Technology and Waste Management, with whose support and guidance this Vidnyan Mahotsav could be planned and executed in such a grand and systematic way. May I kindly request Shri Atanasio Monserrat, sir, to speak a few words on this occasion.
Distinguished guests on the dais, Dr. Pramod Sawant, the Honorable Chief Minister of Goa, Sri Joe Manuel Noronha, Sri Punit Goel, Professor Christopher Brett, Professor Prem Shankar Goel, Professor Raghavendra Gadekar, Sri Ramesh Verma, Professor Sunil Singh. At the onset, let me congratulate Organizing Committee for organizing Manohar Vigyan Mahotsav 2022. Government of Goa, through Department of Science and Technology and Waste Management, has been organizing this event on the birthday of ex-Chief Minister and ex-Defense Minister of India, Sri Manohar Parrikar. Late Chief Minister Sri Parrikar had been instrumental in applying the principles of science and technology and innovation towards the developmental projects of the state. It was his dream to inculcate scientific temperaments in young students of the state and to develop them for love for science. The present government under Chief Minister Dr. Pramod Sawant has carried forward late Manohar Parrikar's vision in science and technology and innovation. Various schemes for schools and colleges have been framed for organizing science exhibitions, science seminars, besides and to encourage researchers. Schemes are also framed to support college students in their projects work as part of curriculum, besides for students to visit institutions of national repute. My department shall ensure that the students of the state and institutions and researchers are supported in their projects concerning science and technology and innovation. In fact, government has taken steps to set up Goa State Innovation Council in a private engineering college at Don Bosco, Fatorda Marga. This council has been doing excellent work under the chairmanship of Sri Joe Manuel Noronha. Manohar Parrikar Vigyan Mahotsav 2022. This year is being held besides in NIO at 7 other institutional colleges in the state simultaneously, being attended by around 5,000 students. I am sure events like this will go a long way in developing a love for science and technology and innovation in Goan students. I wish you all the very best for this event. Thank you.
Thank you so much, sir. Friends, we are indeed honored with the gracious presence of Honorable Chief Minister of Goa, who's very able, innovative, hardworking, and who follows the footstep of great leader, late Manohar Parrikar, as far as development, growth of Goa is concerned. May I kindly request on behalf of everyone present here to Honorable Chief Minister of Goa, Dr. Pramod Ji Sawant, to guide us on this occasion. Dr. Pramod Ji Sawant.
Good morning, friends. Good morning. Awesome. On occasion of birth anniversary of Manohar Parrikar, the 4th edition of Manohar Parrikar Vidnyan Mahotsav, distinguished presence here, Sri Antanasio Montserrat, the Minister for the Science and Technology, Sri Jose Norona, the Chairman of GPSC, and the Chairman of Manohar Parrikar Vidnyan Mahotsav, Dr. N. Kailas Levy, Director General of CSIR, New Delhi, Sri Puneet Kumar, CS, Sri Christopher Brett, it is the Coimbra University, Portugal, Professor Raghavendra Gadkar, Sri Ramesh Verma, Professor Sunil Kumar Singh, Director NIVO, and eminent scientists who are delivering the lectures at the various venues. Dr. Tessie Thomas, Professor Aridhan Ghosh, Dr. Ashish Lee, Professor B.S. Jangodar, Professor Dr. Pravinder Meni, Professor M.K. Janardhanam, Dr. S. Chandrasekhar, Dr. V.K. Singh, Dr. Purnima Jalial, Dr. Sindhura Ganapati, Dr. Anil Bharadwaj, Professor Tapas Kundu, Professor V. Kamakoti, and Dr. Andret Kulasu. I'm extremely happy and delighted to be the part of this event today. Our government has marked this day as the Manohar Parrikar Vidnyan Mahotsav to commemorate the birth anniversary of late Sri Manohar Parrikar, former Chief Minister of Goa and Defence Minister of India. Science, technology and innovation very close to his heart, and he used this decision making in the governance of the state. I'm happy to see that this event is becoming the flagship event of the Department of the Science and Technology. The students, teachers, and researchers are looking forward to the date to listen and to interact with the scientists of the international repute. This is the 4th edition. On this day, the 17 scientists are interacting with our students in 8 venues. This, I'm sure, will help to inculcate the scientific interest and temperaments among the participating students and teacher community. I congratulate Minister of the Science and Technology and his department for ensuring this event as meticulously planned and organized by identifying the eminent scientists from the different fields. The department has signed the MOU with the Principal of the Scientific Advisor, the Government of India, Professor A.K. Sood, and Director General of CSIR, Dr. N. Kailas Levy, who are helping the department in identifying the scientists. I'm sure this association will continue in future too. I want our Goan student to become the prominent scientist and contribute for its progress worldwide. I'm glad that Professor Christopher Brett, who has come all the way from Portugal and who was a part of the Oxford University to talk and interact with our student here. I'm very proud to note that this year our Goan daughter and who studied in Goa, Dr. Andret Kulasu, the senior staff and software engineer, manager at Google, and who has crowned her name in the International Circle of Eminence. Today, she is speaking on artificial intelligence. I'm sure, and she will be the inspirations to all. My government is emphasizing on the quality education using the advanced scientific tool and technology. Indeed, this is an opportunity that one must utilize it for our advantage and the future development of our state in terms of scientific index. To my knowledge, this year, the 5,000 students are participating at various venues, besides which the event will be live streamed on social media, where all the general public can participate and acquire the knowledge and information. On this occasion, I want to urge for all the schools and higher secondary and college across the state to arrange the visit of the students to the places like the National Institute of the Oceanography, Donapal, National Institute of the Polar Research, Vasco, the Solid Waste Management Plant at Saligaon, Spilled Waste Management Plant at Kakora, and the Solar Rooftop Power Plant at the Secretariat Porvorim, and also at Goa University, etc. This will develop the strong liking among the children towards the science and technology. Developing the strong scientific temper among the Goan society in long run will be the tribute to this Vidnyan Mahotsav organized in the memory of our Manohar Bhai. I also ensure that this event will be supported by the government in the years to come. On this occasion, I want to announce that henceforth we are giving the Manohar Parrikar Young Scientist Award across the India. This award will consist of the 5 lakhs rupees, and this award will be the annually, and this is for the scientist of 35-year-old and below. So it is the Manohar Bhai's wish to give the Young Scientist Award in the name of Manohar Parrikar Young Scientist Award. From the next year onwards, we are giving this award in the same function. We will give these awards. Thank you, one and all.
Thank you so much, Honorable Chief Minister Dr. Pramodji Sawant, for these words of encouragement. Every edition of Manohar Parrikar Vidnyan Mahotsav was special and unique, and so is this edition. May we make this edition, this moment, more memorable and cherishable. I request Chairman Sir Narona to present mementos to all the guests as a token of our love and respect. Honorable Chief Minister, sir, please accept this memento. Thank you, sir. Minister for Science and Technology, Honorable Shri Atanasio Monserrat. Chief Secretary, Dr. Puneet Kumar Goyal. Secretary, Science, Technology and Waste Management, Shri Ramesh Verma. Professor Sunil Kumar Singh, Director, NIO. Professor Christopher Brett. Dr. P.S. Goyal. And Professor Raghavendra Gadakkar. Thank you, sir. I now kindly request Honorable Chief Minister to present a memento to Chairman Sir Naronaji, who has taken care of all the nitty-gritties to make this event happen. So please. Thank you. I now request Secretary Science and Technology, Shri Ravesh Verma, IAS, to propose words of thanks.
Thank you very much. First of all, sir, we sincerely thank our Honorable Chief Minister, Shri Pramod Sawantji, to declare the Young Scientist Award from the bottom of heart from Department of Science and Technology. Thank you very much, sir. All the distinguished guests present here on dais, Shri Pramod Sawantji, Honorable Chief Minister, Government of Goa, Shri Atanasio Mansarat, Minister for Science and Technology and Waste Management, Government of Goa, Shri Jose Manuel Noronha, Chairman Goa Public Service Commission and Chairman Advisory Committee of Manohar Parrikar, Vidnyan Mahotsav, Shri Punit Goyalji, Chief Secretary Government of Goa, Shri Christopher Braid, and all the other dignitaries present here on dais and in front. It is my honor to thank the Honorable Chief Minister Dr. Pramod Sawant for his presence and addressing the gathering. I also thank the Honorable Minister for Science and Technology and Waste Management for his gracious presence and addressing the gathering. I must thank Professor Christopher Braid for being present and for delivering the lecture in our classes. I would also like to thank Principal Scientific Advisor and his team for all corporation for their support and for this event for the last 4 years, and we look forward for their support in near future. I'm extremely thankful to the Secretary, Department of Science and Technology, Government of India, Dr. S. Chandrasekhar, for being present and talk to Goan students. Besides, I'm also extremely thankful to Professor Raghavendra Gadkarji, Professor, Indian Institute of Science, Bangalore, for being part of this event. Besides, I would also like to thank eminent scientist speakers who are here in Goa in different locations, Dr. Tessie Thomas, Professor Arindam Ghosh, Dr. Ashish Lele, Professor B.S. Jagankar, Dr. Parvinder Mani, Professor M.K. Janardhanam, Dr. S. Chandrasekhar, Dr. V.K. Singh, Dr. Purnima Jalihal, Dr. Sindhura Ganpati, Dr. Anil Bhardwaj, Professor Tapas Kundu, Dr. Andrea Kolkau, Professor V. Kamal Koti. My special thanks to our Director, National Institute of Oceanography, Dr. Sunil Kumar Singh, for all his support he has provided to us for this event. I would also thank to the Chairman of the Advisory Committee, Dr. Jose Manuel Noronha, for organizing this event meticulously, not only this year, but also in the all previous years. I sincerely fail in my duties if I do not thank the associated partners, that is the various departments helped to organize this event, National Institute of Oceanography, Panji, Goa Public Service Commission, Goa Waste Management Corporation, Center for Environmental Education, Goa State Council for Science and Technology, Goa State Pollution Control Board, Goa Energy Development Agency, Goa State Innovation Council, Forum for Innovation, Incubation, Research and Entrepreneurship, Directorate of Higher Education, Directorate of Education, Directorate of Technical Education, Department of Information Publicity, and Goa Tourism Development Corporation for their all support to organize this event. Last but not the least, I would like to thank all the sponsors for this event, Deccan Fine Chemicals India Private Limited and Dempo Group of Companies. Thanks to all to be with us today here. Thank you very much.
Thank you, sir. With this, I declare the end of inaugural session. But friends, let us congratulate the organizing team, as we are following the minute-to-minute schedule exactly on time. We had said 10:35 will be the end of inaugural session, and please check your watches, it is 10:35. Let us congratulate. As it is said, well begun is half done. Thank you so much. Thank you all the dignitaries. Request all the students to kindly be seated, don't leave the hall. We are beginning with the technical session just in a short while.
Good morning, students. We will be starting with our technical session now. I request all of you to please sit in the auditorium itself. So we'll be just starting.
Which is the best tribute any common man? To Goa, that will be the best tribute.
Similarly, I request Professor Christopher Brett, Dr. P.S. Goel, Professor Raghavendra Kadakkar, and Dr. Sujit Kumar Dongre, Scientist E, Environmental Center for Environmental Studies, to come and occupy seats on the dais. Friends, as we all know, this endeavor is to promote scientific temperament among the students. And what was found in last 4 years is that students are really interested and they wait for this festival. They also get opportunity to interact with great scientists, eminent speakers on one-to-one basis. So students really wait for this festival. Once again, a kind request to students to take maximum possible from this particular festival organized by Government of Goa. I request Chairman Sir Jose Manuel Noronha to introduce first speaker for the day. Can we have the lights off, please? Students, please come as fast as possible and settle as soon as possible. I can see the group of students over there at my left-hand side. And I can also see seats vacant. Students, please take your seats and settle down.
To Manohar Parrikar.
Sir, over to you. Sir Jose Manuel Noronha.
Yeah, very good morning once again. We are very happy and content that Professor Brett has agreed to travel all the way from Portugal and come here. So I will very briefly introduce Professor Brett to you. He'll speak for 35 minutes. There's a Q&A session. Remember that this session of Professor Brett is being telecast across 7 centers in Goa. There'll be question answers that will come even from them. And those who are listening to me now, there's a WhatsApp app that is made available at your center. If you have a question, do ask. It will be sent here. We will go through it. And as many questions as Professor Brett can answer after his talk, we will try to accommodate that. Professor Christopher Brett is a full-time professor of chemistry at the University of Coimbra in Portugal and was the president of the International Union of Pure and Applied Chemistry 2020-2021 and is now past president 2022-23. He is also a member and vice chair of the UNESCO Basic Sciences Program, Scientific Board for 21 to 24. After his MA and DPhil in electrochemistry at the University of Oxford, he spent a year at British Petroleum London before moving to Coimbra in 1981. His research interests have focused on the development of new materials in electrochemistry and their application in different areas, particularly in sensing. This has included new nanostructured electrode materials and nanomaterials on modified electrodes, the use of electroactive and redox polymers, corrosion and its inhibition, electrochemical aspects of green chemistry, electrochemical sensors and biosensors. I think all the young ones are listening to big words. Remember, he'll speak, he'll explain this to you. Most recently, he has been exploring deep eutectic solvents for the preparation of nanostructured materials with different properties than those made in aqueous media and room temperature ionic liquids for electrochemical sensors and biosensors. He is the director of the Electroanalysis and Corrosion Laboratory Institute Pedro Nunes, that's at Coimbra, the technological innovation link between University of Coimbra and the industrial sector, which provides services in analytical electrochemistry, environmental chemistry, and evaluation of corrosion. He was president of the Ibero-American Society of Electrochemistry 2022, was president of International Society for Electrochemistry from 2007 to 2008, and president of the Analytical Chemistry Division of the Portuguese Chemical Society 2018-20. We are indeed honored to have you here, Professor Brett, and we look forward to hearing from you now. Thank you.
Thank you very much for the very kind introduction. For me, it's an honor and privilege to be here, taking part in this science festival, which I think is an absolutely wonderful initiative for everybody, not just for young people. And I hope that I can tell you some of the things that I think are fascinating about chemistry, the chemical elements, and a little bit about what I do, and perhaps the questions that you have at the end, and I'm sure there will be many, will help to explain maybe some of the other aspects. Because in 35 minutes I can't tell you everything. I need many hours. And also, of course, talking to a young audience is very similar to talking to an older audience. All of you have where you understand, maybe not all the long words, but all the other ones, certainly. And so it's just like talking to colleagues in many ways. And of course, there's curiosity. Curiosity is what's behind scientific progress in the end, and I will show you 1 or 2 examples of this. The title. So if you think about the world of the chemical elements, it's actually absolutely everything we deal with. We are dealing with all the elements. They're bound together. They make compounds. Fantastic. Why? Because it's really interesting. We can do so many things, and we can do it, I hope, sustainably, if not now, then in the future. And I was very happy to see and hear already this morning how much Goa is doing towards sustainability. The planet needs it. It's not just India, it's not just Portugal, it's all of us. And also talking about the world of the chemical elements, there is art. It's not just science. We need to ally this with art because it's something that gives us pleasure. It's something we all appreciate, and I think it makes something that's already beautiful, which is the periodic table, I shall mention even more so. Just one quick word about where is Coimbra. So Coimbra was the first capital of Portugal in the 12th to the 13th century. It's in the center part of Portugal. I think that the pointer is not working really. Let's see if I can get the other one to work. Yes, so it's here where you see this, this green circle. So the university was founded in 1290, and here you see some pictures of the university. You see the old part here. This is where the chemistry department is on the hill. This is the old part. It was the king's palace that he gave to the university. This is from the 12th century. This part is newer. And what you see here, these are the ceremonial halls, and what you see is gold. And that's the first element. I'm going to talk about just a few elements. Gold. Why do we see gold everywhere? And the reason really can be seen here on this slide. Here we have gold, and you can just dig this up. Gold nuggets. You can find them in the ground. There are not many of them left in this state now. It's normally much smaller particles because all these big ones have been found. But it's the metal. That's the point. And so that's why we have the gold standard. It's not the silver standard or iron standard, it's the gold standard, because this is, we say it's noble, it's inert, it doesn't change. It's also soft, we can work it, and we can do things like these beautiful Indian bracelets. I chose this deliberately for here, of course. But sometimes you can get things a little bit wrong. And here we see pyrite. You can, of course, look here at the crystal structure and you say, no, it's something a bit different. But very often when you see it, it looks exactly the same. So this, of course, is curiosity. What's similar? What is different? What can we find out about these things? And then we take another completely different element, iron. Iron is one of the most important metallic elements that we have. It's very abundant in the Earth's crust. It's less abundant in aluminium, but not much less. And we can make it by reduction of iron oxide that you see here underneath. The iron oxide is red, and it's what we see on the surface of iron and steels when they undergo corrosion. So we take iron ore out of the earth. We use coal, or even better to use coke to extract the iron, and we get something like what you see here. It looks like a piece of cake or a pie. That's impure iron. That's exactly as it's made after extraction, and from that we can make steels, all sorts of steels. Some of them look fantastic. Stainless steel looks wonderful. And it's here in an industrial installation where one cannot have corrosion occurring. So iron is an oxidizable metal. Like most metals, it wants to return to its natural state, which is the oxidized form. We don't have many metals that don't want to. We have gold, we have platinum, silver, and we call these the noble metals, and they all come from the same part of the periodic table. And here we see a periodic table as we will know it now. And as you can see, the elements go up to 118. That is the latest element, the last element that has actually been confirmed and has a name. The name is organesson. And I wonder how many of you young people know why it's called organesson. And please don't all answer at once, because you're in different places. It's named after the person who was crucial in the synthesis of the latest elements in the periodic table. So these last elements here. And so he is a Russian scientist who was responsible for a lot of the research, and it was decided and agreed by nuclear physicists in many countries that this was quite appropriate that it should be called organescent. So he's something like 86 years old now. And so this is another point. The last elements are not natural. They all have to be synthesized in special cyclotrons and so on. So this is an ordering that perhaps even to you seems natural sort of ordering at the moment, and it's not. This systematization, of course, had to be found. And there's a sort of beauty in it. And I was giving a talk a couple of years ago which was linking art and science. And so art, of course, music is part of art. And so I looked up the word symphony, because the title of the symposium was Symphony of the Elements. And so I looked in the dictionary, and there are 3 definitions that one finds very easily. And I think for you here, perhaps the third is the more interesting one, because this is linked to Western music, of course, but this last one not. Symphony is a lengthy piece of music or harmony of sounds or colors. So harmony, that's the word that's important. And so here you can see synonyms that come from the dictionary. And we see here harmony, of course, balance, and so on. And if we think about the chemical elements, we do need balance. There has to be a balance between them. Certain reactions, yes, others, no. It's not about destruction. It's more about construction than it is any destruction. And so in 2019, there was an international year of the periodic table. It was led by IUPAC, of which I was president just after this year, so I was president-elect at the time. And so it was to celebrate the chemical elements and not only see how they benefit us, and at the same time look at emerging technologies. So which are the emerging technologies that are most important for us? And we have a list of 40 here. It started 2019, we've just had 2022. And so one of the things that you can see that comes in most of the years is the word battery or something similar. For example, in 2019, we have solid-state batteries. Down underneath, we have dual-ion batteries. And then if we go to this year, we have sodium-ion batteries. So energy, electrical energy. And this is, of course, linked to electrochemistry. So this, I think, points the way to what some of the things that we hope we will be doing in the future. And many of them have to do with sustainability. The batteries certainly do. Using energy efficiently, recycling the materials. And again, we'll come back to that. So where did it all start? Of course, people have been thinking about these things for millennia, but there were 2 things that happened at the end of the 18th century that really began to change the way we were looking at the world and at the chemical elements. So Galvani did something that was really just lateral thinking out of the box, as we would say nowadays. So connecting frogs' legs and their trunks, their bodies with a caliper, which is made of metal, and inducing movement, nerve impulses. This is electrical impulses. And so he called this animal electricity, of course, because he didn't understand it. We're now just beginning to understand that properly, because it's actually really complex. Important almost straight away was the invention of the battery, as it's called here. It's called a pile, because a pile is vertical, a battery is horizontal. So it's several electrochemical cells in series vertically. And so he made these using paper and using zinc and so on, and he was able to generate a voltage, what we call a voltage now, after Volta himself. So this enabled all sorts of things to be done. So it's the first, what we would now call battery, of course. So Humphrey Davy was able to extract metals that are very reactive, like sodium and lithium and potassium and strontium. And this was a very important step towards constructing the periodic table, which allows us to predict things. And then Michael Faraday became very much involved in this and formulated the laws of electrolysis. And he also formulated electromagnetic induction, which is something we, of course, associate with electric power, in particular at the moment, turbines in electric power, in power stations. And so, as a result of all this, in the 1860s, several eminent scientists of the time were trying to see how they could put all this information together that they had in blocks, but how to put these blocks together. And so that led to the periodic table, and often associated particularly with Mendeleev, because he predicted that elements would exist where there were holes in the table itself. And so here we see one of the early periodic tables. And this is what he actually wrote on the left when he formulated the table. And on the right, you can see something that makes a little bit more sense to read, because this is obviously in his handwriting. This is just taking the upper part. So what you see here are question marks. So he was predicting what would be there. And where it says 68 is actually gallium. Gallium is an interesting metal because it's at room temperature, it's only one of the two metals that is liquid. And the other one, as I'm sure you all know, is mercury. And so he predicted that there would be elements with these atomic numbers. And that was shown, in fact, to be the case, and gallium was the first one to be found. And so this is all on periodic table wall in St. Petersburg. There is a statue as well, as you can see on the left. So we've got the periodic table, and it's usually shown in that form, but it can be shown in many different ways, because we have the groups that I'm sure you know about, going from top to bottom, where the properties are similar. There's a gradation of properties, and then we go left to right, which is the periods, we call the periods. And then it just stops at the end. But why don't we join them together and make a cylinder? Yes, you can. And you can do all sorts of things. And this is just showing some of the nice ways that you can represent. And I'll show you another one in a minute. So this is a sort of spiral construct. And this is a construct of everything we have so far, except we haven't got there. This is Oganesson here, 118. And then it's going to carry on in some way. Maybe this representation is wrong. We don't know yet. We don't have 119, 120. But anyway, there's room for it in this periodic table. That's why I like it. But this is what we normally show. And then we can look at the isotopes. So the atomic number is what we use to construct the periodic table. So the number of protons in the nucleus. But we can have different numbers of neutrons, and that gives us the isotopes. And so if you have a radioactive element, then you can't really say there's an isotope X and Y, and one is 25%, the other's 75%, like happens with chlorine. You can't say that. So they're white here. And of particular interest, I think, is this one here, is technetium, which is an interesting element. It's used actually in medical diagnostics. So this was the opening ceremony of the periodic table in Paris. You see here a Japanese periodic table in a fan structure, which is really very unusual. And this is Oganesson himself talking about these latest elements. that, of course, some people say are not chemical elements because they don't exist in nature. But we'll talk about them a little bit anyway. These are some of the medical applications of chemical elements. And so many are used in medical applications. Interestingly, you've got lithium here. Lithium is also, we associate with batteries at the moment, but it's also used in medications, as many of you probably know. And so before I actually go to look a bit more deeply in some of these aspects of what we should do with the elements, let's just look at a few of the compounds. On the top left, we have vases or pots being made out of clays. And so that's, of course, a combination of elements. They're made out of silicon, very often silicates, and so in different ways. And so underneath that we have glass. So the top is ceramics, the bottom is both ceramics and glass. And so the red color in the glass here is due to gold, what we call nowadays gold nanoparticles. So very tiny particles of gold, maybe 50, 100 nanometers diameter. They used to be called colloids. That is not used so much. And these China objects here, the middle ones are from China itself, with these wonderful colors on the surface due to different elements that are used in the glazing. Just remember, one of them is cobalt for blue, and is really wonderful. And of course, in painting, exactly the same thing. You have the pigments that have very similar colors. Sorry, at the top, we have a technical ceramic. This is titanium nitride in this case. So something that, an unusual combination of elements that can give us special properties. Here it's for brake discs in cars and other pieces that we'd use, for example, in aeronautics. Silicate minerals, wonderful. But in the middle at the bottom is asbestos. It looks fantastic, but it's not very healthy for us. It's not one of the forms of silicate minerals that we can actually, that we actually want to use. Of course, this wasn't realized till about 20 years ago, and so now it's being removed. So we come to the natural elements, and this is a really interesting diagram, I think, because it shows how much of the elements we have that we can readily remove from the Earth's crust, how much there is, how easily we can remove it, and behind that, do we actually need it? So something like hydrogen, you see here, is green because there's a lot of it, and it's not going to run out. You look further to the right, you have oxygen, the same. Under hydrogen, we have lithium. So lithium has a yellow color because it's not, the resources are not inexhaustible, and maybe they're a little bit difficult to get to. And so most of the other colors, well, you can see strontium, for example, underneath is red. And there are one or two elements which are black, and that means they're, in this particular slide, that means that they are from conflict minerals. So that's usually the country that is involved in that. So this gives you a picture of how things are. But then somebody said, well, what about carbon? Should we be showing carbon as green? There's a lot of it, and obviously it's essential to life. But what about all the carbon dioxide we're producing? Climate effects. And so a committee decided that it should have three colors because of that. One is black, another is red, another one is green. So conflict resources rather than conflict minerals. Conflict resources means coal, essentially, because we're all having to move away for this in a sustainable world. But there are other things with carbon. It's not just that. There are the nanomaterials, carbon nanotubes, graphene, many things, really interesting things are being done with these nanomaterials at the moment. There's a lot of research going on in how we can use carbon nanotubes and graphene, and they conduct along the plane and along the tubes here. And we're looking here at something that's 10 nanometers, 10 to 15 nanometers in diameter. It's really very small. And of course, we can make metal nanoparticles like the gold I mentioned with these dimensions. And let's not forget something. I put this in because I think it's really interesting and maybe points the way to the sort of things you can do if you think laterally. So if you have aluminium, another very important metal in our present-day world, you can oxidize the surface artificially and make this hexagonal template that you see here, alumina template, and then you can fill it with gold by doing a reduction reaction and make nanowires or nanotubes of gold inside there. Then you can dissolve away all this aluminium oxide and you just have them freely available to put where you want. And this is important for catalysis. And so if it gives us good catalysis, it's something we're interested in. It means saving energy, probably getting better quality products. So sustainable development, yes, we need to do it. And all of the sustainable development goals are ones we interact with. Science, STEM, so basic sciences interacts with most of them actually in different ways. And you see here the symbol of the International Year of Basic Sciences for Sustainable Development. That's the current year. And this was felt and proclaimed by the United Nations because it is so important. So basic sciences, as I think I said at the beginning, are curiosity-driven. But we need them. We need to have this lateral thinking. We need to ignite new ideas of how to look and solve the world's energy problems. So the International Year is about advanced research, yes. It's also about education and outreach to younger people like yourselves. And so there's an excellent website which you can look at and see some of the initiatives that are going on. This is reminding you, of course, about the climate action difficulties that we have, and the COP27 that was in Egypt. I don't know if you were following it at all on the news, was not a complete success in the different nations agreeing to cap their carbon dioxide emissions, energy use, etc., with a timeline that was seen by this report here to be necessary. But that's another talk, if anybody is interested afterwards. Okay, so within the sustainable development, we have green chemistry. So green chemistry means not producing toxic waste. It means doing things in as clean a way as possible. And there were 12 principles, and these are all listed here. It has a lot to do with solvents and things like that. And here you see it's also to do with design for degradation. And these are about 25 years old. And so if you look at my field, and it was just mentioned here, very briefly on the right, electrochemistry. Electrons are clean reagents, so long as we make them cleanly, of course. And so these are some of the things in which electrochemistry is, and I'm not going to dwell on this except to point out that here, apart from big electrolysis processes that you need for making aluminium, you need it for making sodium hydroxide and chlorine. We have corrosion, but here we have solar energy conversion and batteries. It is all electrochemistry and sensing as well. And so some of the things I do are more in this lower part here. And so the batteries, here we've got the back of a car full of lithium batteries. You can see it needs a lot of lithium if we want to go that way. And so thinking about the fact it's yellow, what do we do? Well, we have to look at alternative batteries, of course, but assuming it's lithium, where do we get it from? There's lithium everywhere, but very dilute. If you want something more concentrated, you have to go to somewhere like this, which is the Atacama Desert in South America, on the borders between 3 countries, and it's very high up in the Andes, 3,000 meters. And so there are some big salt flats there with high concentrations of lithium. And so that's one way you say, okay, we make a lot of lithium, and so there should be no problem. Okay, but it's not enough. So at the very least, we will need to do recycling. And this is, of course, one of the other points. So some people say we can't do this, so we have to use fuel cells, for example, in cars. And this is a hydrogen fuel cell for a car. You have to store the hydrogen. You have to have it, first of all, maybe by water electrolysis. You have to, or even of sodium chloride. So you have to store the hydrogen, and that's not really so safe. And then you need a battery as well, of course. And this is the sort of way we're going, with electric cars by batteries and also fuel cells. And I think that that's something that will be happening much more all over the world. So this is another periodic table that was issued, comes from an article written by Anastas, who was the author of the Green Chemistry Principles, and Zimmerman. And it's different. You probably can't see there, but what it's doing is showing all the problems and the advantages and some limitations of using green chemistry, table of green elements. This was mentioned in my introduction. It's something we do. I think it's quite interesting. You can take 2 solids, you mix them together after heating them up a little bit, and you form a liquid. And this is due to what is known as the eutectic effect, so strong interactions between 2 components, and then you make a liquid. And so they're called deep eutectic solvents, and you can see one mentioned here. Why should we want to do that? Well, all sorts of things. It can be metal deposition, it can be for extraction, or it can be for sensing purposes. And here, this is for sensing. If you look at the slide, you see here you have 3 peaks. So this is in a sensor, and that's for 3 uric acid that you often find together. It's telling you you can, if you make a modified electrochemical sensor in the way that I described in deep eutectic solvents, then you can do this and separate the 3. And you have the waste that you have is essentially non-toxic. So this is a certain advantage, a definite advantage for the future. You can use nanoparticles on your electrode surface together with what's called a redox polymer that you can electropolymerize on the surface in deep eutectic solvents. And this is looking at an antibiotic called dapsone, just showing that it works. You can see it works because you get these increasing peaks here with concentration. And that's what people are looking for, of course. And here this is a biosensor with an oxidized enzyme, choline oxidase. And what you see on the surface, this time you see multi-walled carbon nanotubes and gold nanoparticles. So 2 nanomaterials. This is the other trend at the moment, to use as much as you can of these nanomaterials if they enhance your response, enhance your sensing. And they do. So what about the future? I've been talking a little bit about the future anyway, but we need new materials, new nanomaterials, not just nano, larger as well, that we can make economically. We should learn many lessons from COVID-19, doing things in a green way. You remember all industry stopped and the air became clean. How can we approach that through new methodologies? So rapidity, if you're looking at sensing as well. We must have the fundamental science to underpin technological applications. So we cannot have everybody just doing technology. Basic science must be done as well. And people have to learn about that. And it's really interesting because it's curiosity driven, of course. And so for sensing, there are a number of things there that I don't have time to go into. So I just want to mention one final thing, the recycling, the circular economy. Circular economy is an ideal. You can't actually do it completely because you're bound to have some residuals and you have energy consumption. So there's always something. And this is just one example of how you could use cellulose waste to make gluconolactone commercially or for lighting. So it's using a biofuel cell in the, you see here in the third box from the left. And so this is an idea. It works in the laboratory. It needs to go outside, of course. And so finally, I'd like to acknowledge everybody who has helped me reach this stage over my career so far. So my research group and collaborators, many interesting discussions, many difficult questions from people, from young people in particular, and financial support, of course. This is Coimbra once again. And so finally, to remind you that the chemical elements is everything. It's fantastic, it's fascinating, not just fantastic, and the future is sustainability. And thank you very much.
Thank you, Professor Bright. It was wonderful indeed. We have opened this lecture at 8 different venues, yes, and everyone is listening to you. I have received one question from farthest venue, which is very southernmost part of our state, a place called Kanakona. The student is asking, why do diamonds last forever? Why do diamonds last forever?
So the question, why do diamonds last forever? Because they are structurally and energetically so stable. They're almost perfect in terms of the structure. So it's carbons linked tetrahedrally to other carbon atoms, and there are no defects in the structure. If you make diamonds synthetically, which you can do, then the concentration of these defects is higher. And how do we know this? In part because they are not so hard. Their hardness is slightly less. Of course, diamonds are made naturally under conditions of extremely high pressure, not natural conditions at all. You can do some interesting things with synthetic diamond. You can dope it with boron, and then the properties are very different. It actually conducts electricity. So, yes, I hope that answers your question.
Thank you very much. So now I think we'll go for a second. Any students who have any questions to Professor Bright? We can take one question perhaps from here. Yeah.
There's a question there. Yeah, the question is why use lithium for the batteries rather than sodium? It's a technological question as much as anything else. The technology of the sodium batteries is not yet good enough. Lithium, there was an emphasis on lithium, partly because it's a lower atomic weight, and therefore it should be more efficient. Lithium is a bit more reactive than sodium. And so the emphasis in the development of technology was on that. So thinking of the mass. But we have to go to sodium because sodium is inexhaustible. There's enough around everywhere for us. And we don't have to go to 3,000 meters in the Andes or do open pit mining. Actually, in Portugal, there is a place where there is lithium that can be extracted, but there are all sorts of environmental problems with the mining, extraction, and so it's a fairly small operation. So that's the reason. I think it's not because people don't want to do it. It's just not reached the sufficient technological level yet.
Thank you, Professor Brett. Thank you very much.
Okay, thank you.
Thank you, Professor Brett, for a wonderful lecture. Now we are moving ahead with the second technical lecture by Professor P.S. Goel, who is the former Secretary of Ministry of Earth Sciences. He's going to speak to us on science, technology, and society. I have an honor to introduce Professor Goel. Prem Shankar Goel was born on 20th April of 1947 in a village called Dabasarai, district of Moradabad, UP. He did his BE in electrical engineering from University of Jodhpur, Masters of Engineering in Applied Electronics and Servo Mechanism from Indian Institute of Science, Bangalore, and PhD from Bangalore University. He started his career with initiating activities on satellite attitude control system for spinning RS-1 satellite at Trivandrum, and later moved to Bangalore as part of Aryabhatta project team. He developed spine axis orientation system Bhaskara 1 and 2 satellites, magnetic control for spinning Rohini series satellites, momentum-based 3-axis control system for Apple, zero momentum biased 3-axis control system for IRS-4, configuration momentum-based attitude control system for highly stabilized INSAT-2. He also developed a very agile control system with step and stair capability for spot imaging mission, TES, and guided the evolutionary of re-entry capability through SRM systems. Sir has been in forefront. He has also worked in ISRO and many places. We are fortunate to have you, sir, here to speak to our students as part of Manohar Parrikar Vidnyan Mahotsav. Now I request Professor P.S. Goel to continue.
Thank you, Mr. Goel. Distinguished dignitaries on dais are also in the front rows. But most important, today's you are the student who are real guests or real most important people. I was approached about 2 days back by Dr. Sunil Singh ji, and when he asked that can I speak on this occasion, there were 2 reasons I said immediately yes. One was I happened to know, rather meet Sri Parrikar ji on 4 or 5 occasions. The last one was in Goa, in his house. Our meeting was largely regarding restructuring the DRDO. Of course, that couldn't happen because of his health. And the second reason, of course, was I don't normally leave the opportunity to talk to the students. So that's really very important because you are the future of this country. And that's one of the reasons that I thought I should really take this opportunity to talk to you. And also, it's really great honor when I'm talking on the occasion of, which actually remembers Sri Parrikar ji, who was a great man, not only great son of Goa, but also great son of India. Why I chose this topic? One of the reasons was I was sitting at the Science Institute, NIO. Basically, I'm a technologist. And also, I realized that when we are talking to the students, it's important that the students really are able to connect the society and science and technology, because our Prime Minister thinks of India of 2047. And by the time, me and my contemporaries will be gone, but you would be shaping India. You would be shaping the society. So that was perhaps the main reason I immediately chose this topic. But when we talk of science and technology society, I think we need to go back to our history. Go back to the way we evolved in this country. It's very important to really get back to our heritage. We are one of the oldest civilization, perhaps the most old civilization in the world. And we talk of, we have been talking of technology since the time immemorial. You know, the Vedas are said to be something between 9,000 to 7,000 old. And in those Vedas, there's a lot of mention about technology, the so-called Vimanas. The astrology had evolved even at that time. Indian astrology is one of the oldest, and it has migrated towards the West through so-called Arab countries and the further West to Europe. So when we look at various technology developments, like Ayurveda, also a science developed at least 4,000 to 5,000 years back. And we have been talking of Akashvanis and many other things. So when we look at where we were, you know, in 5th or 6th century, India was producing 60% of GDP of the world. We were the richest country. And that were only because of this technology development. The so-called Mohenjo-daro culture or civilization, which disappeared somewhere around 3,500 years back. I have seen myself Lothal near Ahmedabad, and you see the development at that time. The so-called drainage system, the system for supplying water, the technology for developing beads, and that was at least 4,000 years back. So why we were so rich in so-called 5th or 6th century is largely because of these technologies. The spices from India were going all the way through all the Europe. And that's why there was a sort of curiosity what India is, and people were coming here to discover. Our agriculture was well developed, our yoga was well developed. So all that has happened, and that has happened much before the rest of the civilization even really learned how to speak. And you know, we developed the concept of zero, the decimal system, which was not existing, and which has enabled the rest of the science and technology to evolve. And why I'm mentioning this to you, only to recall, if we connect to our past, if we connect to our heritage, then it gives us a sort of feeling that we can do a lot more. But then, what happened? Why is it that when we were 60% GDP of the world in 5th and 6th century, why it happened that we lost it? One of the main reasons is, again, goes back to our culture. In the sense that we didn't have the notion of nation. We were always treating Vasudhaiva Kutumbakam. The whole world is our family. And when the whole world is a family, the concept of fighting was not there. And once that was not there, and of course the second thing is that we also had this concept of be satisfied what you have, which developed later years. And once you are satisfied, then you lose the urge to innovate. You lose the urge to do scientific work. And perhaps these were the two factors that we really, you can say, could not fight those invaders. For 1,000 years or so, we were ruled by the invaders coming from various countries. And afterwards, for another 200 years, the Britishers came. And all that is, of course, part of history. You must have learnt a lot already. But the point is, why we lagged? We lagged because we forgot actually Gita. On one side, Gita says that you do your karma. Other side, he also says, when Krishna says, I'll come back whenever there is a papa or pap. We forgot to punish pap. And that was one reason that we really got into the situation that when the war started, when somebody started coming to rule us, we were always on a slower side. We did not invest in the development of fighting the war. That's because we were believing in Vasudhaiva Kutumbakam. And that's why when the enemy came with horses, we were fighting, our people were fighting with just without on foot. When Babar came, he came with cannon, and we didn't have. So we were one-sided. When the Britishers came, Britishers have a small gun. And that by the time Babar had given us cannon. Now you cannot fight a war with cannon when the opposite person has got very flexible guns. Very recently, you have heard about 1962 war with China. We had a defeat. Why? Because Chinese had automatic guns and our Jawans having one at a time, 303. You can't fight with that. 1965 war with Pakistan. Pakistan came with very advanced fighting machine like Saberjet. We were having our net. Absolutely no comparison. We won that 1965 war, but that's in spite of the fact that we didn't have a proper fighting mechanism. That's because our pilots were very well trained and theirs was not. So sometimes, of course, human skills can be advantageous, but in this case, the fighting machines with Pakistan were much better. So these are some of the things which we really have to really recall that why this happened. Now, the question is, can we break this tradition? And when I was interacting with Parrikar ji, some of these thoughts were there, and that's why he wanted to do restructuring of our capability to invent in terms of the fighting machines. Now, let's look at today's world with respect to science and technology. I recall a statement from Professor Sarabhai. You all know that he is the father of Indian space program. He started thinking about space in 1963. And he was talking about development of rockets, development of satellites. And he was also a great scientist in the X-ray astronomy. In one of the meetings in 1966 in Geneva, he was asked a question many times, why a poor country, and that time we were really poor, why a poor, underdeveloped country like India should be investing in space technology, in rockets and satellites? And he gave an answer that if we have to develop our country, if we have to develop our society, then we should be second to none in the application of science and technology for men and society. So that was in 1966 that he really connected science and technology to the man and society. And he believed, very sincerely believed, that space technology is such technology. How we have done by developing rockets, by developing satellites, by developing various applications. Today, space connects to every one of you. You carry a mobile, the complete GPS system is supported by satellites. We have our own equivalent GPS system in the form of Gagan, or in the form of Navik, and all that is happening. So he had that vision in 1966, and actually if you really talk to anyone from ISRO, he starts his speech with this quotation of Sarabhai, and that is a sort of Gita for us, because whenever we look at this space program, we always look at what it will do or it can do for the man and society. So that's something very, very important. Now when we look at other developments, actually it's Sarabhai who started many of these things. You know that he instituted or created 29 different institutions. 28 of them are surviving today and doing very well, including, of course, the management. There was no concept of management in India, and he was the first person to start the Indian Institute of Management in Ahmedabad. So like that, many things he did. And that is the result, nuclear power. Actually, he was the first person to think of that, yes, the nuclear power, in addition to power, will have to also act as a deterrent. And whatever happened in the Pokhran 1 in 1975, it was largely the drive of Professor Sarabhai. So we have done very well today in space, we have done very well today in nuclear, we have done very, very well in many activities, including our own corona vaccine. Can you imagine if India had not its own vaccines in corona in time? It would have been a devastating effect. So the role of science and technology in each and every field. When we are talking of last century, the last century was, first half, was largely the half century of science. If we have to go back or look at the history of science, the most important contribution came from Newton, which was almost 500 years back. But then in the early last century, we got from Newtonian physics to what we call as Einsteinian physics, the theory of relativity, the quantum physics. These were the developments which were actually, you can say, led the world. In the later half, the science started getting converted into electronics or into applications. Electronics is one application. Microbiology, everything actually resulted from the science which was generated in the first half of the last century. And the development which have taken in the second half are, of course, mind-boggling in every area you take, whether it's aerospace, aeroplanes, transportation, communication, including mobile, internet. These are all result of science and technology. And each of them has a very large, significant impact, including, of course, the national defense, which I was talking earlier. But then when we have to go to the 21st century, this century, actually this century is a next development. And this development is innovation. Now, what is the difference between the so-called science and technology and innovation? I will just recall one incident. I was reviewing IIT Delhi as a member of a committee about 10 years back. And when we found that, okay, there is so much good work being done in IITs. Science and technology, we are doing very well. But what was lacking? We are lacking converting our technology into products. And that has been a problem for last almost 30, 40 years in our country. We have got excellent engineers, we have got excellent technologies, but we lack the so-called ability to convert that technology into products that can be used by the society or sold to the society. Can we imagine that so-called idol of Lakshmi or Ganapati coming from China, so cheap that we don't buy what is produced in India and we buy China-built Ganapati, and that's what's happening. So where is the problem? Problem is our ability to create things on based on basic knowledge, or which is already existing. So what is innovation? Innovation is nothing. It's not a new science. It's not even a new technology. It's our ability to connect different fields together. We have to make a mechanical engineer to talk to electronics engineer, or a materials person, or a physics person, or an optics person. So we have been doing our engineering, our science in isolation. We were not talking to each other. In fact, that was the lesson we learned in the space right in the very beginning. In fact, Professor U.R. Rao, who can say, if Sarabhai is the father of the space program, U.R. Rao is the father of the satellite program. And he used to tell that we are best engineers, best scientists, but we don't know how to work together. And that is one thing he started teaching us in his space. And now you imagine that if you have to develop even a toy comes today with a battery, with a lot of electronics, with a lot of visual things with different colors and all that. No, you cannot do that if there's only one person in isolation. So, you know what sometimes he say, that in mathematics, 1 + 1 is equal to 1, but 2. But in real life, 1 + 1 can be 1. If two electronics engineers work together, they don't add to each other's, they don't complement, they don't add to each other's strength. So it's 1 + 1 is equal to 1. But if the two different engineering disciplines they join, that it can make an 11 because you can create a product. So point I'm trying to say is, this century, and when you are growing, when you are getting into the work, you have to really make sure that you work together, you innovate, you have to bring synergy. And for that, it's not the question of science and technology. When I'm talking of creativity or I'm talking of innovation, it has to be in every field, whether you are a person in finance, whether you are doing business. You know, the concept of doing things together, or rather the innovation, there is just a simple sort of story I will tell you. You have all heard about the tortoise and hare story. Okay, the two fellows ran, the tortoise went faster, then it slapped near the goal, and the hare slapped, and then tortoise won. There is a next version of that. The tortoise went next day to the hare and said, let's do it again. So here this time, he decided that I'll not sleep. He went and won the race. So what happens? 1-1. Then tortoise thought of again, okay, I should win this time. So he told him that, look, this time we'll run. I will tell you where to run. So he chose a target across a lake. So hare ran fast, but tortoise, even though it was slow, in the lake, he went fast and won the race. But then they realized, by the time they became friends, that look, this way is not going to work. Let's now have a race with any other animal in the world. What you do is, on the earth, the hare will carry the tortoise. On the water, tortoise will carry the hare. And so that both together, they can win against anyone. So that is what's called synergy. That's what is called innovation. So we need to bring that kind of a thing, ability to work together, and then be product-oriented. If we are able to do that, that's something you can do great wonders. We have to think of doing new things. Now, when we talk of our own role, each one of us is born with some purpose. Now, most of the time, we really fail to discover. And so where the effort has to be, when you grow, when you complete your study, when you get to the so-called world where we have to really produce, this is a phase after 25 years or so, what we used to call earlier, that you are getting into Grastashram. Actually, you are getting to an age where you are giving back to the society. And in that, you have to really see how you make a difference. The ultimate essence in life has to be how to make a difference. Whether you are a scientist, whether you are an ecologist, whether you are working on environment problems, whether you are working disaster problems, doesn't matter. Can we make a difference? And in this context, I just remember a small documentary I saw some 10 years back. The documentary is like, in fact, Nasiruddin Shah, he was playing a lead role in that documentary. A writer was sitting on a beach like Goa. He was looking for some ideas. He found that a young man was walking across the coast. He was picking something, throwing back into the water, and just passing. And he did some few times when this writer saw it. He came next day, same time, and he saw the same thing. Got a curiosity, and he went to the person who was picking something and throwing into the ocean. He asked, "What are you doing?" He said, "This jellyfish, it comes along the wave, it just lies here, it will die, so I'm throwing it back into the ocean." The writer was a knowledgeable person, scientist like you. So he said, "Look, the Indian coast itself is 7,000 kilometers. The coast around the world is more than 1 lakh kilometers. So if you walk 1 kilometer a day and you throw something into the ocean, what difference does it make?" This young man, he didn't say anything. He was just continued walking. He picked up the next one, threw into the ocean, and he said, "It makes a difference to that one." The point is, the difference doesn't have to be earth-breaking. Difference has to be small, but each one of us has to make a difference. And where means it is what you choose. The field you are working, whether you are a businessman, whether you are in service, or whether you are a scientist, or whether you are just a mechanic. Each one of us, we have to make a difference. And that's what is important in life. There are multiple ways of serving society. The politicians have their own way. The scientists have their own way. If you're a manager, you have your own way. But everywhere, one has to think that, okay, my duty, my nation comes first. And this is something which we really can learn from Parrikarji. Whatever interaction, very small interaction, 4 or 5 meetings I had, never I heard a sentence about him. He was always showing concern. Of course, in this case, because he was that time defense minister, so all the time, what way the new technologies or new developments should really lead the world. So ultimately, the essence of life is that we should be contributing to society and keeping country in the first. That's the probably best way we can pay our respect to Parrikarji. One more thing which we have to really see, that's something this Ukraine war has showed us. Most of the time, we look at ourselves, we look at progress, we look at how well the society is. But if the nation is not secure, no, if you see last 10 months, a very flourishing country. In fact, when you really look at the history of Russia vis-a-vis Ukraine, it's very interesting. That's a civilization, again very old, grew parallelly with Russia, but the czars, the so-called kings of Russia, they never allowed to really, in the last 300-400 years, they were only dominating that. Actually, in the last century, Ukraine became free in 1917 and up to only 1921, only 4 years. And afterwards it became free only in 91 after the breakup of the Russia, so-called USSR into Russia. And there, still they wanted to revive their culture, revive their heritage. But now the issue is not the land. Issue is the land of the culture, of the heritage. Similarly, you see these in our neighborhood. Tibetan was a very old heritage and culture. Where is it? It's really just on paper. Now, if we have to save our sons, we have to first save our country. And that's the message perhaps Parrikar wanted to give to us, to all of us. I'm saying that our younger generation is much more brighter, much more intelligent, and you can say much more committed. So I see a bright future for the 2047 and looking forward a much better India, a great India, and the #1 India for 2047 with your efforts. Thank you.
Thank you very much, sir, for enlightening our students about the historical perspective of what the science and technology, and also how the role of young generation in creating a world which is more sound in science and technology. We will have a next lecture, and then perhaps I think we will open up the venue for questioning. We will be having the last technical session of the day, being delivered by very eminent ecologist, Professor Raghavendra Gadakkar. He will be speaking on a topic that is very important and very interesting, considering the current era of science and technology. Professor Gadakkar will be speaking on science for all, how to do a cutting-edge research on a shoestring budget. So it is his topic, and I am very honored to introduce Professor Gadakkar, who I said is one among very few people in the world who have studied on sociobiology of insect. Professor Gadakkar has done his BSc honors and MSc in zoology from Bangalore University and PhD in molecular biology from Indian Institute of Science, Bangalore. During the past 40 years, he has established an active school of research in the area of animal behavior, ecology, and evolution. The origin and evolution of cooperation animals, especially in social insects, as I said, such as ants, bees, and wasps, is a major goal of his research. By identifying and utilizing crucial elements of India's biodiversity, he has added a special Indian flavor to his research. Professor Gadakkar is now Year of Science Chair Professor at the Center for Ecological Sciences in the Institute of, and also an honorary professor at the Indian Institute of Science Education and Research in Mohali, and non-Indian permanent fellow of the Institute of Advanced Study in Berlin. Professor Gadakkar has spent a number of years in the Indian Institute of Science, Bangalore, doing great research in the field of ecology. I now request Professor Gadakkar to deliver his talk, and after his presentation, I request all of you to pose a question for both Dr. P.S. Goel as well as Professor Gadakkar. Sir, please.
slide. Now it's come. Yes. Good afternoon, everybody. I see lots of young faces also on the top. It's a great pleasure for me to be here as part of this Mahotsav and speak to young students. I have chosen the topic Science for All. How to do cutting-edge research on a shoestring budget. Let me begin with what is science. Science should be a curiosity-driven, playful exploration of the natural world. Unfortunately, modern science has become an expensive, almost industrial activity, heavily dependent on sophisticated laboratories and expensive equipment. There are many consequences of this. There are local consequences. This has had the effect of making most people, and especially young students, feel that doing science is beyond their reach. And all they can do is to learn what other better endowed people have done. So students often feel that we have to learn, somebody else will teach and we have to learn. In my opinion, this is the most serious problem facing science education in India. The feeling that students feel that we only can learn and we cannot do. There are also global consequences of this industrialized kind of science. At a global level, this tends to make developing countries, like India for example, mere consumers rather than producers of knowledge. So just as students feel that senior people produce knowledge and we consume, people in developing countries feel that developed countries produce knowledge and we are only to consume. And yet, many major new discoveries in science still come from unsophisticated, playful exploration. I want to convey the message that science is a playful, curiosity-driven exploration which everybody can indulge in. All of you can indulge in. Let us not confuse between science and technology. These are two different things. A high school student or a retired school teacher may or may not be able to contribute to the development of new technology because it requires many things that they do not have. But a high school student or a retired school teacher or a farmer or a layman or anybody, they can surely contribute to the development of new knowledge. And this is what we should remember. I want you to pay close attention to this cartoon. There are two panels. One is called Big Science and one is called Little Science. And what you see inside the panels is in the Big Science, you have Einstein sitting with paper and pencil. And on the right side, you have a big factory or a laboratory. And the cartoonist has labeled that one as Little Science and this one as Big Science. Because the ideas come from exploration, from paper and pencil. You don't need big equipment for getting the ideas. And that's what one should remember. What I will do in this lecture is using my own field of natural history of animal behavior. I study animal behavior. And using that, I will illustrate how interesting experiments can be performed by almost anyone who is curious and committed and without necessarily having access to a sophisticated laboratory. So I mainly study social insects, as was mentioned in the introduction. I study ants, bees, and wasps. And I want to introduce the field of animal behavior. The science of animal behavior is technically called ethology. Ethology is the scientific and objective study of animal behavior, usually with a focus on behavior under natural conditions. This is a simple layman's definition from, in fact, a dictionary. But let me give you a slightly more sophisticated definition of animal behavior. And now I'm going to quote a very famous scientist, in fact, one of my heroes, called Peter Medavar. Peter Medavar and his wife, Jean Medavar, they wrote a book called A Philosophical Dictionary of Science. And in that dictionary, one of the entries was ethology. And their definition of ethology is very interesting. So this is Peter Medavar. they say the word ethology is not merely an alternate designation for the science of behavior. It is a term that stands for a genuine revolution in biological thought. Ethology is rooted in observation of animal behavior, an activity that only simpletons think is simple. They go on to say that observation itself is a difficult and sophisticated process, calling upon all the intellectual virtues, attention, patience, heightened awareness, caution in coming to conclusions, courage in framing expectations. Now, instead of talking about this instrument and that instrument and this laboratory, what you need are these virtues: attention, patience, heightened awareness, which all of you have. You may not have a sophisticated laboratory, you may not have access to many other things, but you have all of these, and you can cultivate all of these. Thus, I'm trying to show that science is something that you can do. It's not just you have to learn. You can actually do, you can contribute. No, it's not stable. We'll put it there. We'll put it there. I'll take it later. Don't worry. In fact, the first ethologist was none other than Charles Darwin himself, and he laid the foundation for the environment. But later on, ethology developed. In fact, it developed to such an extent that in the year 1973, even the Nobel Prize came to the field of ethology. So these three famous scientists, Carl von Frisch, Konrad Lorenz, and Nicholas Tinbergen, were awarded the Nobel Prize for the study of animal behavior in the year 1973. Now, let us remember what they said. Ethology is based on observation and experiment. And ethology claims to reveal the minds of animals. So ethologists feel that they can understand the minds of animals. This is a tall order. Is it really possible? Can we really understand the mind of an insect, for example? So I study insects, which are fairly low down in the evolutionary scale, and they're very small, they have very small brains, but their behavior is very sophisticated. Can we understand this? So as I said, I will illustrate a few simple experiments that anybody can do. So I have chosen 6 experiments to talk to you about. 5 of them are by famous people. The last one is by my student, who is not yet very famous, but probably will become very famous in the future. And I will show you how all of these experiments cost nothing, but they require patience, awareness, intelligence, observation, coming to conclusions, not money, not laboratory, not equipment. All of you, every single person in this room has all the ingredients required to do these experiments and produce knowledge. That's why I'm using these kinds of examples. So the first experiment I will illustrate, which was done by the Nobel laureate. So there were 3 Nobel laureates, I said. One of them was Nico Tinbergen, and he did this first experiment. He was a Dutch scientist, and later on he spent much time in Oxford, and he was very fond of animals, including insects, and he would walk around in the woods and he would observe insects. In particular, he was interested in this wasp. This is a wasp. This is a solitary wasp. Later on, I'll talk about social wasps. Some wasps are solitary, others live in groups. So I'll talk about the group living wasp in the end. This is a solitary wasp. What these wasps do is they dig holes in the ground and they build their nest inside. And once they dig a hole in the ground, I'll show you here. So they find food, they bury the food inside that, they lay an egg inside that, they close it and they go away. The egg which is laid on the food hatches, eats the food and becomes an adult wasp and comes out. But once the mother closes the hole and goes away, the mother is no longer there. The baby has to come out by itself. But many times the wasp has to come and bring food. And what Tinbergen observed was there were many, many small holes in the ground, but each wasp was going to its own hole. He says, how does it know? In all of this confusion, how does the wasp know this is my nest and not go to the neighbor's nest? So he argued that maybe they use visual cues. Maybe they use their eyes and they use visual cues, or they may be using smell. They may be using olfactory cues.
And in order to see whether they are using their eyes or smell, he did a simple experiment. So here in this slide you will see that this is the nest, this is a drawing of the nest, and what he argued was, suppose they were using their eyes, suppose they are using visual cues, they may be learning very special features of the landmark around the nest. So there may be some grass growing, there may be a stone here, there may be something here, which is different from other nests. So that's how I recognize my nest. Now to test this possibility, he said, let us make these visual landmarks more conspicuous. Very simple. So he said, I don't want to do anything sophisticated, I don't want much money, I don't want it. So he just picked up a few pine cones. Lots of pine cones, dried ones, were lying on the ground. He picked them up and he surrounded the nest with these pine cones. So this nest now became very special because it was surrounded by pine cones. And he said, if the wasp is using vision, then it will learn that the nest hole, which is surrounded by pine cones, is mine, and it will go there. But if that is not what it is doing, then it will not be any addition. So what is the experiment? Then what he did was that he trained the wasp to go in and out. So after putting the pine cones, he waited for some time. The wasp goes out, brings more food, keeps it there, goes out and comes back. After he did several times, he assumed now this wasp must have learned that my nest is surrounded by pine cones. Now, is it going to use this information to find its nest or not? It may have learned, but it may not use that information. So he did an experiment in which what he did, he was a little, see, to do this kind of experiment, you also have to be a little bit mischievous. You have to try and fool the animal. So what he did was, after the wasp had gone away, he removed the pine cones. Now what will the wasp do? And to make matters worse, he dug a little hole on the side here and he put pine cones there. That's not a real nest. That's a sham nest. So now what will the wasp do? If the wasp thinks that my nest is covered with pine cones, then it will go to the wrong nest. If it knows its own nest by some other method, maybe by smell, then it will go to the correct nest. So simple question to ask is, when the wasp comes back now, will it go to its own nest, which has no pine cones, or will it go to the new nest, the sham nest we call it? It is not really a nest there which has pine cones. So can you fool the wasp to go to the wrong nest? If they are using vision, then you can fool them. So he did this experiment. So in fact, when the wasp comes back, he would see where it goes, and then he would shoo it away. It comes back again he'll see where it goes. That way he was able to count many, many times what the wasp is trying to do. How many times does it go to its own nest, which now does not have pine cones, and how many times it goes to the other nest, which has got pine cones. And he counted this, and he came up with a very simple idea that almost always, see this experiment with pine cones, and it never went to its own nest. Every single time it was fooled, and it went to the sham nest because it was paying attention to the pine cones and not to its own nest. So around the nest, not what is in the nest. Now, he was not satisfied with this. So he did another experiment, and here in this experiment what he did was, you can see here, he put the pine cones back to the original nest. Now when the wasp was away, he took all the pine cones from the sham nest and put it on the real nest. Now what should the wasp do now? We expect now it will go to the real nest, and you can see that every time it went to the real nest, never went to the wrong nest. So by this simple experiment, he showed that wasps use vision and they memorize the landmarks around their nest and use those landmarks. And therefore you can fool them by shifting those landmarks to another place. But he said, but they may also use smell. Do they ever use smell at all? So to test that, he did another experiment in which he again put pine cones, but in addition to the pine cones, he just put two small pieces of cardboard. And in this small piece of cardboard, he put some strong smell. See, what he is doing in each case, he is exaggerating. Originally, there were some pebbles or something around the nest. He exaggerated that by putting pine cones. Originally, there may be some smell. He exaggerated that by putting cardboard with smell. And he trained the wasp. So the wasp went and came back, went and came back. It had the opportunity to learn the visual landmark, the pine cones, if it wants. It also had the opportunity to learn the smell if it wants. Now when the wasp comes back, what does it do? So what does Tinbergen do? He leaves the smell in the original nest and takes the pine cones to the wrong nest. So if smell is important, it will go to the original nest. If vision is important, it will go to the wrong nest. You see the point? So that's what he has done in the lower part of the graph here. And what does he find? It never goes to the real nest with the smell. It always goes to the wrong nest with the pine cones. That means smell is not important. Vision is important. So in the first experiment, he showed vision was important. But with that first experiment, he cannot say smell is not important. With this experiment, he can say both the things. Vision is important and smell is not important. And again, reverse experiment. Now he turned around and he put the pine cones in the original nest, smell in the wrong nest. And it did not go to the wrong nest, it went only to the real nest. So wherever the pine cones are, that's where it's going, it's not going to the smell. So with these two simple experiments, he showed that wasps find their unique nest by vision and not by smell. Using similarly simple experiments, Tinbergen discovered many other things, which I will only mention and not give you the details. He showed that cones soaked in alcohol, that is descented, worked as just well. See, whenever you come to a conclusion, you must doubt your own conclusion. In science, you should never be overconfident. You must say, I may be wrong. So he said, I have shown that they go wherever the pine cones are, and I am concluding that they are not using smell. But maybe the pine cones have some smell. They may be using the pine cones not by seeing them, but by smelling them. It's a possibility. So to rule out that possibility, he took all the pine cones, he went home and soaked them in alcohol so that their chemicals are all gone, and then he took them out, he dried them. Now there are smell-less pine cones. He repeated the experiment with smell-less pine cones, and again it worked. That means they were using the vision of the pine cone and not the smell of the pine cone. Wasps with amputated antennae also. The other thing he did was, the wasps smell, see they don't have a nose like us. They have two antennae and they smell with their antennae. So he said, if I remove the antennae, then if they need to use smell, then they cannot find their nest. So he cut off the antennae. Still they were able to find their nest with the pine cone. That means smell is really not required. The wasp could not be trained on scent alone. So now he said, let's forget the pine cones. Let me only put scented cardboards and let us see I can make the wasp learn the smell. That is, in the absence of visual cues, can it now go back to olfactory? And the answer is no. So you can see he did repeatedly experiments to show that vision is important. The visual landmarks were recognized from up to 100 to 200 meters away. Even when the wasp was 200 meters away, it knew that is my nest. It seems to have pine cones around it. In real life, of course, not pine cones, but whatever be the visual landmark. So he discovered this important thing, and this was in the early part of 20th century, where none of this was known. Now just reflect, what did he need to do this experiment? What did he need to make these discoveries? He didn't need money, he didn't need a laboratory, he didn't need a teacher, he didn't need anything. He was a young man at that time. He just used common sense, interest, went out, playfully, he tried to fool the wasps. In fooling the wasp, he made major discoveries. Similarly, I will take you through 5 more experiments. So experiment 2 is by the other Nobel laureate, Carl von Frisch. Carl von Frisch was very fond of studying, again, many animals, but just like for Tinbergen, wasp was one of his favorites, for von Frisch, honeybees were his favorite. And he actually got the Nobel Prize because he discovered that honeybees have a dance language. And I'll have one experiment about the dance language. But before we go to the dance language, I want to talk about another experiment that von Frisch did, because apart from showing that by simple, playful exploration, curiosity-driven exploration, you can make major discoveries, there's one more fact I want to illustrate using this experiment. So you're all familiar with honeybees. Honeybees live in these large colonies where many bees are there. But if you look carefully, there are 3 kinds of bees. There is a queen bee in the center here. There are some male bees which we call drones, which are on the left side. And then there are a large number of small bees, female bees, which we call worker bees. As you know, the workers do all the work. Queen lays eggs and males are lazy. Males don't do anything. Now, workers, after working from home in the first part of their life, they go out and they collect nectar and pollen, bring it back to the hive. And von Frisch was very interested in studying these bees. And the way he studied these bees was, unlike Tinbergen's wasps, where he had to wait for the wasp to do whatever, Carl von Frisch realized, because honeybees are social, they live together, and the bees are always going out to collect nectar and pollen from flowers, bring it back, deposit it, go back, bring it back. Because they are depositing at home, they are always need of more. So he fed, honeybees are always hungry. Why are they always hungry? Because if they eat, they will be satiated. But they don't eat. They go and deposit at home, they come back, so they are perpetually hungry. Because they are perpetually hungry, I can train them. So he trained bees to come wherever he wants and collect sugar solution. So here Fawnfish is sitting in the garden. There's a small wooden stool, and on top of that he has a glass bottle in which he has put some sugar solution. That's all that is needed. No sophisticated laboratory is needed, and he has some scented sugar solution. Now what he does is he keeps this stool very near the beehive. So bees come out and by accident they just find it. They're very happy. So they take a little bit of nectar of the sugar solution, go home, deposit it, come back, take some more, and then again you have to be mischievous. So he said, now I want to fool the bee. So he takes that stool and moves it away a few meters. Now the bee comes back and is very annoyed. What happened to this stool? There is no sugar here. But very quickly it searches and says, it's here. So he takes it back, goes back. Then after some time, he moves it another few meters. And the bee does the same thing. And he keeps on doing this, and therefore the bee comes wherever he wants it to come. In fact, my students do this, and we bring bees from kilometers away, around the building, on top, through the window. They can even come and sit on my microscope for me to observe them, because that's where I put the sugar solution. So wherever I keep moving the sugar solution, they'll keep coming there. So by such way, he was able to do many experiments. But just like Tinbergen said, how do the wasps know which is my nest? Cornfish asked a question. It's very important to ask questions. When you observe, you must wonder, how does an animal do this? Why does an animal do this? Sometimes you will feel that the questions are very absurd. Many times your teachers, your parents, your elders will always tell you that's a stupid question. There is no such thing as a stupid question in this world. Only there are stupid answers. Questions are never stupid. So no question is stupid. So Carl Fawnfish asked what many people may say is a stupid question. He went out, looked at flowers, beautiful flowers, brightly colored. And what is the question he asked? Why should this flower be brightly colored? You can see, what a silly question. But he said, it's important to ask this question. Why should a flower be brightly colored? So what would your answer be? Clearly, it cannot be to satisfy us. Why? Because bees evolved 60 million years ago. We evolved recently. So bees have been flowers have been brightly colored for a long time. They evolved 60, 50 million years ago. So there must be some other purpose why the flowers are brightly colored. Now it's common observation that honeybees will go to flowers and collect nectar and collect pollen. And when they do that, they go from flower to flower, and they accidentally transfer pollen from one flower to the other, and that's how the flowers get pollinated. The plants get pollinated. You are aware of that, right? Get pollinated, and that's how plant reproduction happens. So the plants are dependent on the bees for their reproduction, for their sexual reproduction. And therefore, it is in the interest of plants to attract bees. This is common sense. And so Fawnfish said, flowers may be brightly colored because they want to attract bees. Makes sense. But there's a problem. Everybody knew at that time that bees cannot see colors. It was believed that bees are colorblind. Why? Because bees are small, they have small brains. How can they be able to see color? This was just an impression that people had. So he asked, why are flowers brightly colored? Is it to attract bees? But then bees must have color vision. And everybody knew that bees cannot possibly have color vision. They didn't know because they did experiment. They always thought it's not possible. Many of the things we believe are not because we really know, but we think it must be like that. But there was an interesting problem. An eminent ophthalmologist called von Hess, who had written an authoritative book on vision science, and he had been knighted, he became Sir. He was a very famous man. He concluded on the basis of some very sloppy experiments under very unnatural conditions that all invertebrates and even fish are colorblind. So this was established by a very famous scientist. Unfortunately, his experiments were very sloppy. Von Frisch was a young man. He was not impressed. He says, why should I respect what this great man has said? I will try and find out myself. This is the spirit that all of you must have. Why should I believe my teacher? Why should I believe a Nobel laureate? Why should I believe Professor Gadagkar? Let me try and doubt him. Let me try and disprove him. Science is the only field where if you want to prove somebody wrong, that's a good thing, not a bad thing. So he said, I'm not convinced. I'm going to do my own experiment. And he designed a very simple experiment. In fact, the experiment was so simple that that experiment has been repeated thousands and thousands of times by everybody. 10th standard, 11th standard school children come to my lab every year and I make them repeat this experiment. Anybody can do this experiment. And my students, in fact, have simplified this experiment. I'll show you not how Von Frisch did the experiment, but I'll show you how my students do the experiment. My students means I work in Indian Institute of Science, Bangalore. There's a Kendriya Vidyalaya attached to the Indian Institute of Science, and those students come to my lab because they have to show that they have done some experiment. So what we do is we just have a cardboard box, and inside the cardboard box, we keep a bottle with some sugar solution for the bees. But the bees have to enter the box. And what we do is we close the box, and we have two small holes. The bees have to enter by one of these two holes. And around these holes, we put cardboard pieces, simple cardboard with color paper. So go to the shop, buy some cardboard, buy some color paper, buy some glue, and attach it, and put this. So you see, we have one hole which has a green cardboard, one which has a blue cardboard. Now, what you do is you close one of them. So the bee can only go through the other one. So here is what is called as a training period, where you can see I have marked blue as plus, green as minus. That means the blue hole is open, the green hole is closed. And we wait for the bees. The bees will, like usual, you first train the bees, then they will keep coming. And constantly the bees go in and out of the blue hole. Now, if they have color vision, they should realize that the blue hole gives me food and not the green hole. Okay? Now, you test the bees by opening both or by closing both the holes. Now you close both the holes and ask, where will the bee search? If it has learned that blue is the rewarding place, it should search in the blue. If it is colorblind, then it should search in both. And when you do that, in fact, almost all the bees search, this is the training, and in the test here, you can see that they don't go, okay, in this case it's the other way around, so they don't go into the blue, they go into the green. And there's another problem. Could it be that they have learned that they should go to left and not to right? So you put the same color on both sides, and then they'll go to both sides. So they're not learning left versus right. They're learning blue versus green. But there is a serious problem. Von Frisch said this doesn't prove anything, because I think all of you are too young to realize, but when we were young, we did not have color television. We had only black and white television. But in black and white television also you know different colors, because different colors appear as different shades of gray. So maybe the bees actually don't have color vision, but they see blue and green as different shades of gray. And that is how they recognize them. So to show that this may or may not be the case, he did another simple experiment. He went to the shop and he bought all kinds of gray papers, different color shades of gray, and he put all of them and said, if the bee is learning blue because it is a certain kind of gray, then it should confuse with some gray. So he gave them all possible gray papers and showed that the bees never get confused. It's a very interesting story. It has a happy ending. Now, after Von Frisch did this, and after he published, shockingly, the great man C. von Hess, he refused to accept Von Frisch's results and insisted that it was possible to demonstrate that older claims of another man called Lubbock, as well as the recent ones by Von Frisch, according to which bees can be trained to certain colors, are wrong altogether. So the most famous man said Carl Frisch is wrong altogether. And he said, not a single fact is known that could even make plausible the notion of color sense in bees through my investigations, this assumption has been terminally refuted, is what the great man said. The young Fawnfish stuck to his position, and eventually Fawn Hest was forgotten and Fawnfish got the Nobel Prize. This is the story I want to tell. Don't just accept because an authority is saying something. If you are right, you will ultimately be recognized. Later on, other people, for example, this man called Autumn, he made the final proof. So what he did was the physiologist Autumn obtained direct evidence of trichromatic color vision in bees by so he actually inserted electrodes into the bee brain and showed that they have the particular kinds of cells required for color vision. You all know that we have trichromatic vision, right? Bees also have trichromatic vision. So you can see here in the upper part, this is the human trichromatic vision, where blue, green and red are our primary colors. Bees also have trichromatic vision, but a slight twist is there. Their primary colors are ultraviolet, blue and green. So bees are blind in the red. They cannot see red, but UV they treat as a color. So they can see UV, which we cannot see. In fact, if you look at flowers with UV light, you will find they look very different. So the bees actually see things differently from the way we see it. Now students should ask more questions. So when students come, these 10th standard students come to my lab and they do this experiment, I keep telling them, don't just go by authority. So then they say, why should we stop repeating Fawnfish's experiment? We want to ask more questions. And I'll give you examples of 2 questions that the students ask. One student said, did an experiment of the following way. So they put the nest also, the beehive also in one cardboard box, food in another cardboard box, and they put these color cardboards, and they asked, suppose I fool the bee. See, this idea of fooling an animal is very, very powerful. By trying to fool an animal, you can understand how it does. So what they did here was that at the feeder, they closed the green hole, opened the blue hole. At the feeder, at the hive, they did the opposite. So the bee has to enter the blue hole or the green hole depending on where it is. So when it comes home, feeder, when it comes feeder, it should go to blue. When it goes home, it should learn green. And it only takes 1 second from it to go from feeder to home. But can it do this? Can it know that I am now at home, so I must go to this color, I am now at the food, I must go to that color. And the students did this experiment using the same method, and they showed that indeed that's what they can do. There was another year in which one student said, suppose I want to fool the bees in another way. I set up an experiment where in the morning they have to go to one color, but in the afternoon they have to go to another color. Can they do that? Can they remember the time? So blue is open in the morning, but closed in the afternoon. Green is open in the afternoon, closed in the morning. Can the bees do that? They did the experiment and showed in fact the bees can do. So not only do the bees know where the food is, what is the color of the flower, but what time that nectar is available. This is very useful for bees because flowers in nature are not open all the time. Some flowers open in the morning, some open in the evening, some are blue colored, some are yellow colored, some are other colored. So bees have to remember all of this. So Fawnfish discovered this, and now all of this is established fact. You will read all of this in the textbook. But how was it discovered? By a simple young man, a young boy, not willing to accept the authority of senior scientists. Not willing. So don't accept anybody's authority. I mean, if you're afraid that your teacher will scold you, you say, okay, for time being, but in your mind, you should question. You should question everything. And because, I'm young, I don't have money, I don't have a laboratory. You don't need any of these things. You can do science in every way. So let me take you now to a third experiment. The third experiment is also about honeybees. This is an experiment done again by Fawnfish. I told you Fawnfish discovered that honeybees have a dance line. So here is a bee sitting on a flower. On the flower, the bees collect both nectar and pollen. Nectar they store in a temporary thing called the crop. They don't drink it off because then it will get digested. They have to go and deposit it at home for the other bees. So they keep it temporarily in the crop where it doesn't get digested, and they go home and they regurgitate it. But pollen they cannot carry in the mouth. It's difficult. So in the legs, they have what we call pollen baskets. So they put the pollen in the legs and they take it home and they deliberate. So you will see here, on the legs, on the hind legs here, you can see all the pollen accumulated here. This is the pollen basket. Now when the bees go home, they not only deposit this, so bees sometimes may discover a tree with lots of flowers, plenty of nectar, plenty of pollen. Now if that bee tries to take it little by little home, it will take forever. And also other bees can take it away. So they go home and they recruit other bees at home. Come join me, we will all take it, we'll all take it. But how does the bee tell the bees at home what to do? It doesn't say, come follow me. The bee goes home and performs a dance. Through this dance, it tells the bees at home what I have found, how far it is, and how to get there. So bees have a language. Just as we have a language, they have a language. This is called the dance language. By performing a dance, they are able to communicate this information to bees, and after they go and perform the dance, you can take away the dancer. The bees who have watched this dance will now have this information. On their own now they will go to the tree and collect the flowers. And that tree may be kilometers away, it may be a complicated way to go there, it may have a particular kind of flower the bees are able to do this. And this is what von Frisch discovered. I won't go into other details. I just want to say two things. One is the bees have two kinds of dances. Sometimes the bees will go and just run round and round, clockwise, anti-clockwise. This is called the round dance. There is another more complicated dance where they perform a figure of 8. So they run up, come back, run up, come back. So there is a middle part here which is where they vibrate their wings and waggle their abdomens. Then they come back to the starting point and do this. So there is a round dance and there is a waggle dance. But there is a pointer also. Then I use this. Okay. So what the bees do, what von Frisch discovered was that the bees, so this is the hive, he kept three kinds of places. He kept food in three places. One here, two here, and three here. And he watched what the bees do. And through this he found that when the bees go home, the angle at which they run while shaking their abdomen is very important. So if they're running up, that means the food is in the direction of the sun. If they're running down, that means the food is opposite to the sun. But if they run to the right side like this, that means the food is to the right side. So he discovered that bees use this very simple information. That is, but remember what it means. It means the bees have to measure this angle. Whether the flower is in the tree is in the direction of the sun, or away from the sun, or to the right, or to the left, they have to measure these things. Now, and having measured that, they have to remember that angle. Then they have to come home. At home, there is no sun. So they convert that, they use the force of gravity. So up means sun, down means away from the sun. Using that, they perform this and they learn. Now, in doing this experiment, I will take just one of von Frisch's experiment to illustrate a principle. So here it is. What he did was that this is, so in his little shed, he had a beehive, that's here, and he trained the bees to collect food from this little box here, which was 250 meters away. So 250 meters away from the shed in a particular direction, which is southwest 50 degrees, 250 meters, he kept a sugar solution and the bees learned. Okay. Now the bees learned, they went home and they danced and he took away the dancing bee. Now the bees which had learned by watching the dance, they are supposed to go and find the food. And he wanted to know whether they'll do it correctly. In order to test that, he kept a box without sugar. See where they will search. But he didn't keep one box. He kept a series of boxes and all of them, of course, did not have sugar, and he wanted to know where the bees will search. If the bees have learned correctly, they should go to the middle one. With small errors, they should go to side one, but most of them should go to the center. And you see, that's exactly what they did. Most of the bees went to the center, and only few bees went on either side. There's another important part of this experiment which you may not have noticed. The training was done at 250 meters. the test was done at 200 meters. Why? When he trained the original bee, the food was kept 250 meters away. But when he tested the bees which are supposed to have learned, the empty box which they are supposed to search was not at 250 meters. It was only at 200 meters. Because he said at 250 meters, the original bee may have left some smell. And that is what they may be using, not their knowledge. I want to know whether they are going in the correct direction. So even before they reach 250 meters, they should be in the right direction. And they should find that box. At 200 meters, there is no smell. And yet they should find. And through such experiments, Fonfrisch discovered that honeybees measure. See, of course, the sun is on the overhead. But if you drop a perpendicular from the sun to the horizon, you get a point in space. That is called the azimuth of the sun. So the azimuth of the sun is one point, and the food is in the other point, and the hive is here. So this angle they are able to measure. And remember, and convert that angle at home with reference to gravity. So if the food is 30 degrees to the right of sun's azimuth, they will go and dance 30 degrees to the right. So the original bee measures the angle outdoors, remembers it, converts it inside with reference to gravity. The watching bee learns the angle with reference to gravity, goes out and converts it with reference to the sun. You see how complicated this whole thing is. But the bees are able to do this. Now I'll take you to another experiment. This will also be on honeybees. I'm very fond of honeybees. So it will also be on honeybees. And in this experiment, the knowledge that I have just given you now about the dance language will become very useful. How do bees know how far they have flown? So in the dance, there is information not only of the direction of the food, but also of the distance. Because what is the use of just saying go 30 degrees to the right of the sun? How far should I go? There is also information about the distance. And the way the bees give this information is the way they dance. If they dance very rapidly, that means the food is close by. If they dance slowly, that means the food is far away. So this is how they convey it. But the question is, how do they know how far I have flown? So I go to a tree, it is 1 kilometer away. How do I know it is 1 kilometer away? How do bees estimate the distance they have flown? That's this experiment. But first let me tell you how they convey. So you can see here, this is the distance to the feeding station. In fact, this experiment is from Fonfrisch himself. He kept feeders at 1,000 meters, 2,000 meters, up to 10,000 meters. That means up to 10,000 meters, 10 kilometers he kept. And he measured how fast the bees dance. And if it is very near, they dance very fast, and they become slower and slower and slower. This is how the bees dance. But the question is, how do they estimate? Fonfrisch, the Nobel laureate who did all of this, was also wrong in one way, in one case. He assumed that the bees estimate distance by, or maybe can we have those lights off, please? I can't see the faces. Yeah, those bright lights, kindly switch them off. He assumed that the bees estimate the distance by basically how tired they are. They drink nectar at home, then they fly, and if they are very hungry, they feel they have gone a long distance. This is what he assumed. But it turned out that was wrong. Honeybees are widely believed to assess feeder distances by the energy spent on their foraging flights. However, a critical review of this energy hypothesis, that also I become essentially blind with those lights. Can you kindly turn off those lights? Those two bright lights? They're doing it. Because when I see the light, then I don't see my screen anymore. Yeah, please. In fact, I want the students to see the screen, not me. So don't, the darker the room, the better it is. Honeybees are widely believed to assess feeder distances by the energy spent. This is what was believed. This is other scientists, wonderful, this is how it should be. In fact, this paper was written in 1995. However, a critical review of the energy hypothesis reveals many inconsistencies in these experiments. In fact, new evidence shows that the energy hypothesis is wrong. So these scientists said energy hypothesis is wrong, we'll come up with a new hypothesis. They came up with a new hypothesis which will sound to you like crazy. How can this be? It's a very crazy hypothesis. They said that we will propose a new hypothesis which is called the optical flow hypothesis. Bees use the speed of, so when the bees are flying, the image of the environment is rapidly going backwards in their eyes. So this is what they call optic flow. And they said that is how much optic flow has happened is how the bees estimate. This sounds very crazy to you, but it is not very crazy. And I illustrate that it is not very crazy by telling you, quoting from a Sherlock Holmes mystery story. I hope people are familiar with Sherlock Holmes. Do you read Sherlock Holmes anymore? When I used to read Sherlock Holmes, I still read Sherlock Holmes. Do you read Sherlock Holmes? Anybody familiar? Just raise your hand if you know Sherlock Holmes. No? Nobody is familiar? Okay, so this is a story in which Sherlock Holmes is a detective and he has a friend called James Watson. And in this story, I'll quote from the story. He says, and so it happened that an hour or so later, I found myself in the corner of a first-class carriage flying along en route for Exeter while Sherlock Holmes, so Watson is telling about Sherlock Holmes with his sharp, eager face framed in his ear-flap travelling cap, dipped rapidly into the bundle of fresh papers which he had procured at Paddington. We had left Reading far behind before he thrust the last one of them under a seat and offered me his cigar case. We are going well, said he, looking out the window and glancing at his watch. So he looks out the window, glances at his watch and says, we are going well. Our rate at present is 53.5 miles an hour. So by looking at his watch and looking out of the window, he calculated that they were going at 53.5 miles an hour. Watson thought that Sherlock Holmes had looked at the mile post, which says 1 mile, 2 miles, 3 miles. So Watson says, I have not observed the quarter mile posts. And meaning you must have, and that's how you know what rate we are going. So if you know how many quarter mile posts we have gone in so much time, you can calculate. Sherlock Holmes says, nor have I. But the telegraph posts on this line are 60 yards apart and the calculation is a simple one. So by knowing how many telegraph posts have gone by, in so much time, you can estimate how far you have gone. This is optic flow. So image of telegraph post going past Sherlock Holmes' eyes or image of the forest going past the bee's eyes is optic flow. So a man called Professor Mandyam Srinivasan, who actually got a degree from Indian Science Bangalore, but later went to Australian National University, he and his colleagues decided to test the optic flow hypothesis. Do bees actually measure distance based on the flow of motion? What they did, again remember what Tinbergen did. He wanted to know whether they use visual cues, so he exaggerated the visual cues by putting pine cones. What did Von Frisch do? He wanted to know whether the bees do, so he exaggerated everything. Okay? Now, in this case, he exaggerated the visual field. So he made the bees fly through a plywood tunnel. And inside the walls of the tunnel, so this is Mandyam Srinivasan, this is the tunnel, and he is making the bee fly through the tunnel. And in the walls of the tunnel, he has put this computer-generated graphic, which produces a lot of images, a lot of optic flow. So when the bees fly through this, all of this image goes past their optic flow. And he did 4 simple experiments. And this is very in recent times, so this is 2000. 4 experiments. In one case, he again has his own shed and the bees here. And he had made these plywood tunnels 6 meters long. He put one tunnel, first experiment, here, 35 meters away from the hive, 3 of them here, and the 4th one he just put 6 meters from the hive. Now look at the first one. This has got those patterns, but he put the food at the entrance of the hive, so it should make no difference. Basically, the bees are flying outdoors and collecting sugar from the entrance of the tunnel. But in the second experiment, he put the food at the end of the tunnel. That means the bees had to fight 35 meters outdoors and 6 meters inside the tunnel to find the food. Outside, they will have very little optic flow because the forest is far away. The trees are far away. Inside the tunnel, there will be a lot of optic flow because this pattern is very close. You're getting the point? So, in the third experiment, this is very important, it's a controlled experiment. He, instead of putting this kind of computer-generated pattern, he put parallel lines. So if you fly through a tunnel which has got parallel lines, there is no optic flow. You don't see anything, right? And so there he had parallel lines. And the fourth experiment, just to see whether this works, he put it very close to the hive, only 6 meters from the hive. And his argument was, if the optic flow hypothesis is correct, if bees are measuring distance by how much optic flow is happening in their eyes, then when they fly through the tunnel, a lot of optic flow happens, so they should think they have flown very far. Even though they have flown only 6 meters, they should overestimate the distance they have flown. And therefore, they should overestimate the distance. Now, I already told you that bees perform a round dance when the food is nearby and the waggle dance when the food is far away. When the food is nearby, they just perform a round dance. There is no information about direction. The food is nearby, go and find it. When the food is far away, they perform the waggle dance and they give the information about the direction. So, Srinivasan's argument was that in this experiment, experiment 1, where the food is at the entrance of the tunnel, where the bees have not flown through the tunnel, they should not overestimate the distance because only 35 meters, they should do round dance. But in this experiment, it is 35 meters outdoor plus 6 meters inside, only 41 meters. If you take 41 meters, they should do round dance. But if they have overestimated the distance in the tunnel, then they should think they have gone very far and they should do waggle dance. In the third experiment, because there are parallel lines, the tunnel has no effect. Only the 35 meters outdoor counts, so they should do round dance. And in this experiment, even though it's only 6 plus 6, 12 meters, if this optic flow is exaggerating their estimation of distance, then again they should do waggle dance. This was the prediction. So in these experiments, you set up an experiment, you make a prediction. This is my hypothesis. If the hypothesis is correct, this is what the bees should do. And if the bees do that, then you have confidence in your hypothesis. And you see exactly that's what happened. In experiment 1, mostly round dances. In experiment 2, mostly waggle dances. In experiment 3, mostly round dances. In experiment 4, mostly waggle dances. And this is even more interesting because the total distance the bees have flown is only 6 meters. 6 plus 6, 12 meters. And yet the bees perform a waggle dance. So they really have overestimated. He went further and based simply on this, he actually calibrated the odometer of the bees. You know what an odometer is? You have an odometer in your car which tells you how far you have gone. So the bees have an odometer in their brain which allows them to calculate how far they have gone. And he was able to calibrate the odometer in a very simple way. Again, nothing sophisticated was required. In addition to this, he did one more experiment. He allowed the bees to fly outdoors and he measured how many waggle runs they do per time. Remember I told you if the food is close by, they run fast. If it is far away, they go slowly. That means the number of these runs they do per second is what you can count. And he showed that with distance, the waggle dance duration increases. Because it's farther away, they dance slowly. The duration increases. So this is like a standard graph. So from here you can read off if they do 400 millisecond of duration of runs, then it is 100 meters away. So it's like a graph. So if you measure how long that circuit takes, from that you can tell how far the bee has gone. And using these two information, he actually showed that bees overestimate distance. In experiment 2, for example, where it was kept 35 meters away, he showed that the bees flew 35 meters in the natural outdoor environment, followed by 6 meters inside the tunnel, total of 41 meters. But their dance revealed a mean waggle dance duration of 529 milliseconds, so, which corresponds to a flight of 230 meters. That means by flying only 41 meters, they thought that they had actually flown 230 meters. This is revealed by the projection. Now, A flight of 6 meters in the tunnel was therefore perceived as equivalent to a flight of 195 meters, because 230 outside and 230 in the tunnel and 35 outside, that is 190 for the tunnel. And by simple calculation, that the distance to each wall is 5.5 centimeters. I'll show you in this diagram. Oh, there's no diagram here. So in the tunnel, it's 11 meters wide, 11 centimeters, so it is in the center, so it's 5.5 centimeters, and he calculated the angle at which the image will flow, and based on, he was actually able to calculate that 1 millisecond of waggle dance encodes so much, 13.9 degrees of image motion. So 1 millisecond of waggle dance is equal to so many degrees. So this is what the bees are able to do. Now, this is a very sophisticated thing, but what I want you to appreciate is not how sophisticated the bees are, but how simple-minded Srinivasan was. All he did, some plywood, some computer-generated paper, and he was able to make these major discoveries. Again, I want to drive home the point that you can, all of you can do simple experiments and create new knowledge. That brings me to experiment number 5, and this time I will talk about ants. This experiment is on ants, and it was done by Belgian scientists, and the question they are asking is the following. Now, look at what this says. It is evident that finding the shortest route is extremely important not only for Roman road builders, thirsty rugbymen, and applied mathematicians working on this very problem, but it is also for any animal that moves regularly from different points. How can an animal with only limited and local navigation information achieve this? Many ant and termite species illustrate this problem in the clearest possible way. So if there is a long route to go somewhere and a short route, animals would prefer to use the short route. But how do they know which is the long route and which is the short route? But we know that animals actually always use the short route. But how do they know? Do they measure the long and the short, and do they have some knowledge that short is better? That is the question being asked here, and it is being answered with ants, because it's very easy to answer with ants. So these Belgian scientists used this particular ant called the Argentinian ant, and this particular person, Jean-Louis de Neuberg, said, how do the ants choose the shortest path? So he created a very simple situation in his laboratory. He brought the ants to the lab, and he gave them 2 paths to go to food. So this is what it looked like. Let me see if I have a diagram. Yes. So here, this is the nest, this is the food, and he put 2 glass tubes. On the right side, you see the short path, and this is the long path. And the question is, will the ants use the short path? And if so, how will they use the short path? And he said, let us build a hypothesis. Just like Tinbergen said, I think they use visual cues, or Faunfried said, flowers are brightly colored to attract bees. The Belgian scientist said, I have a hypothesis. And his hypothesis was as follows. All of you know that ants follow each other. And the way they follow each other is, when ants go or walk, they leave a chemical substance behind. This is called a trail pheromone. And that chemical is smelled by another ant, and they're able to follow. You have seen ants go in a line, right? And they all use these chemicals, and that's how they follow each other. And he simply said, okay, he had a simple idea. He said, 2 ants leave their nest at the same time and take different paths. One takes the long path, one takes short path, because they don't know anything else. But the ant that took the short path will come early, return home first, and this trail will now be marked twice as much pheromone as the long path. So if some take the short path, some take the long path, there will be more traffic in the short path because they'll keep coming back quickly, and it will take a long time for them to come on the long path. So there will be more chemical in the short path, less chemical in the long path. The next ant which comes, it doesn't know which is long, which is short. It sees where is more chemical. There is more chemical here, so I'll go here, and automatically they will choose the short path. The colony's efficient behavior emerges from the collective activity of individuals following 2 very basic rules. So the ants don't know anything. They don't know which is the long path, they don't know which is the short path, they don't know that short is better or long is not good. Nothing they know. They only know 2 things. That I should put chemical as I walk, and I should follow other people's chemicals, other ants' chemicals. That's all there. With these two rules, they're able to do something very intelligent, and that is to use the short path. So he did this experiment here, and you can see here, initially, ants took randomly both sides, and here, all of them, you see, they're taking shortest path. They're taking the short path, they're avoiding this. And in order to prove his theory, he actually did a simple mathematical calculation. He did a simple calculation and ran it on the computer and showed that if the ants are doing what he did, then they will actually, I won't go into the mathematical details, but I'll just show you the graph. This is what the computer said the ant should do, the straight line, and this zigzag line is what the ants actually did. So what the computer said the ants should do and what the ants actually did was very, very similar, suggesting that his original hypothesis was actually correct. But he did one more crucial experiment. He said, all this is true, but if I close the short path and allow ants to walk only on the long path, then there will be only chemical here. Now later on I open the short path, what should the ants do? They should not take the short path because there is no chemical. They should take the long path because there is chemical only in that. So the ants don't know which is short and which is long. They only know where there is chemical. And he did a control experiment in which he actually showed that if you close the short path, then the ants will get fooled and they will not be able to take the short path. They are only able to take the long path. So this is what they did. And you can see sometimes what you do has unexpected applications. So when Jean-Louis Denneberg and his students were doing this, in a neighboring university, there was this computer scientist called Marco Dorigo. He was actually a PhD student, and he heard about these experiments, and he said, my God, this discovery by Denneberg and his colleagues that ants find the shortest path and know which is the shortest path by this simple method of measuring how much pheromone there is, has huge applications in computer science. He realized that, and he decided that to change his career path and see how to use this in computer science. In fact, he's written a whole book called Ant Colony Optimization. And he actually showed that you can use this knowledge. So Marco Dorigo and his colleagues have adapted ant-based routing to handle internet traffic. Simulation results indicate that their techniques are far superior to other techniques, and ant-based models are now being used by Southwest Airlines for efficient routing of cargo. So in fact, I'll just quote this, the ultimate application of ant-based routing methods might be on the internet where traffic is slow. The most powerful insight from swarm intelligence is that complex collective behavior can emerge from individuals following very simple rules. Flexible application of swarm intelligence may be limited only by the imagination. In fact, there's a whole branch of computer science called ant colony optimization. So learning from ants, computer scientists are developing algorithms which work much more efficiently than the algorithms they had earlier. So you will never know where useful applications come from. And yet you can see that all that I have described from now, so far, is any experiment that any of you could have done. You need intelligence, you need curiosity, you need passion, and you need to ask questions. You don't need anything else. So there is no excuse for any of us not to do the experiment. So I'll just go to the final experiment which I'll describe very briefly. This is on wasps. So I've talked about bees and ants, now I talk about wasps. And this is the experiment that my student did. I already told you that the males are lazy in honeybees. Similarly, in wasps, the males are lazy. The females do all the work. Please switch off those lights. The females do all the work, the males are lazy. So one student who joined my laboratory to do her PhD, she was very upset with this. She said, why should males be lazy? I can't understand this. Why should females do all the work? And she said, I want to do my PhD on this problem of male laziness. I said, okay, let's find out a way of understanding why the males are lazy. She not only discovered why the males are lazy, but she cured the males of their laziness. This was just her PhD. So we study this wasp called Rhopalidia marginella, like honeybees, but here also the males are lazy. Males of Rhopidium marginata almost, so we wanted to find out why males don't do any work. So what is the work to study? So she said, females constantly are feeding the larvae. So the larvae have to be fed with food. They go out, bring food, and they feed the larvae. They actually put it in their mouth. But males don't do this. So why is it that males don't feed larvae or do any other form of useful work? So we sat together and we said, let us think about this. So we came up with 3 hypotheses. One, males don't feed the larvae because they don't know how to feed the larvae. It's not easy. You have to go and you have to keep it in front of the larva or the mouth. You have to wait for it to take. Males just don't know. They're incompetent. One possibility. Another possibility is that males don't have food enough to give to the larvae. This is because only the females go out and hunt. Males cannot hunt. So the females go out, hunt, bring food, give some to the males, and then feed rest to the larvae. So males just get very little food. They're only just for themselves. They don't have anything extra. That's why they don't feed larvae. Not because they're incompetent, because they never have enough food. Third possibility, most interesting one, is we said the males can feed the larvae. They have food, but they say the females are doing such a good job, why bother? So we tested all of these 3 hypotheses by very simple experiment. So what my student did was she learned to feed the males. So she would take a piece of food and give it to the males and go on giving it to the males. So now the males could not say, I don't have food. He gave a lot of food, and so these are our 3 hypotheses. Why are the wasps lazy? Are they, okay, so they are inability to feed, or they have limited access, or there are presence of females. And she showed when she fed the males enough, they had plenty of food, they actually started going and feeding the larvae. That means they are not incapable. They are capable, but they didn't have enough food. The female wasps don't give enough food to the male wasps. But when my student gave enough food, they started feeding the larvae. So the males are not incompetent, they just don't have food. But there was a problem. They fed the larvae, but very little. Not as much as the females. So my student was not satisfied. Why are not as much as the females? I said, now this third hypothesis is important. Maybe they think the females are doing such a good job, why do I bother? So we came up with a way to test this hypothesis. Very simple. So what she did was, she gave lots of food to the males and she removed all the females. So now there are no females, there are hungry larvae begging for food, and there are males with a lot of food. Now they fed the larvae as much as the females. That's why I said she not only discovered why the males are lazy, but she even cured them of their laziness. In fact, I won't go into the details, but she published a paper where the title was, Males Can Feed Larvae Given an Opportunity. So actually the females don't give them that opportunity. This was the first time in any social insect people were able to understand why the males are lazy and actually how to cure them of their laziness. What I want you to reflect is that all of this required nothing. So what is my take-home message? The process of science is as important as the product. Science is often wrongly portrayed as an elitist activity accessible only to those endowed with large grants and sophisticated laboratories and wearing white coats. Not true. Good science can be practiced by anyone with a sharp mind, even without any grants and laboratories. Science should become a democratic grassroots activity accessible to all, young and old, rich and poor. Every one of you in this room is capable of producing new, important, significant scientific knowledge which may be very useful or at least very interesting. All of you can do this. So in order to promote this idea, I have written a book called Experiments in Animal Behavior, Cutting Edge at Trifling Cost. This book is freely available on the internet for any of you to download. This is the link. You can take a photograph of this if you want. You go to this site and you can download this book. You can read this book. This book has many, many such experiments. I described 6 experiments to you. This has got 16 experiments. And this is freely available. You can download and get this. I also write a monthly column called More Fun Than Fun. This is an example of 6 articles. If you go to this site, you will get 40 of these articles where I describe similar things in a way that almost anybody can understand. So I want to close The Cat in the Hat by Dr. Sui, some of you may know. The quote is, it is fun to have fun, but you have to know how to have fun. So by listening to my lecture and by reading this book and by becoming interested and by realizing that all of you can do science, and science is fun. I hope you will have fun. Thank you.
Thank you so much. On behalf of Science and Technology and Waste Management, I thank all the speakers for their valuable sessions. I hope the students have got motivated and inspired after these sessions. I request Sir Jose Manuel Noronha to come on stage. We are rearranging the stage. That will take just a minute. As all today's speakers were our state guests, Honorable Chief Minister, on behalf of Government of Goa, has an appreciation letter for them. I request our Chairman, Noronha sir, to present this appreciation letters to all the speakers. Professor Christopher Brett, to start with. Dr. P.S. Goel. And Professor Raghavendra Gadakkar. Thank you, Professor Gadakkar. I have another request to our very own chairman to present mementos to Dr. Gopal Mungeria, member of Advisory Committee. So please come and accept this memento. Also to Dr. Sujit Dongre. And I would like to call on stage Sir Levinson Martins for acceptance of memento, who has seen to it that no stone is left unturned. Thank you so much, sir. Sir, and last request for the day to Honorable Chairman to please give closing remarks.
Yeah, good afternoon now from the good morning in the morning. We've had a long session, very interesting. Professor Brett on chemistry. Thank you, Professor. I mean, you showed us that diamonds are really forever, like you say. Thank you for that. Professor Goel, who took us through history of India before 7,000 years back till now. And of course, the dance of the wasps and the bees and the ants by Professor Gadakkar, who enlightened us truly. Before I end, I must sincerely thank Dr. Levinson Martins for all the efforts. He, Sujit Dongre, many nights together. Of course, Dr. Sunil Singh, who we can never forget, Professor Mugreya, and all of you who have come here, thank you very much. We hope to see you here next year again, and have a nice afternoon. Thank you.
Okay, thank you very much. I think it is wonderful having you all whole morning. We also have a lunch for all of you. I request all the students who are patiently listening to all our speakers, request you to please have lunch. and head back to your respective schools and colleges safely. We are so many students here. Do not crowd the area. But in order to make thing easy, we have made several venues. The food counters are there. 3-4 counters are there. Please have a good food and go. Thank you very much.
Thank you. I have a small announcement to be made. All the students, please be seated. We have found a license named Vaibhav Haldankar. Please identify the same and collect it from backstage. Yeah.
Students, you all are please requested to assume your places in the auditorium. Just wait for about 5 more minutes. We will have the guest leave the auditorium to the lunch hall.